There's something out there in the universe that we can't see, can't touch, and don't even fully understand. It's everywhere, shaping galaxies, bending light, and holding entire clusters of stars together. Scientists know it exists, but they can't detect it directly. They call it dark matter. But what if I told you that dark matter might be forming colossal, hidden nebulae, vast cosmic clouds lurking in space, completely invisible to our eyes? What if these nebulae are influencing the universe in ways we never imagined? This is where things start getting weird. We already know that regular nebulae, those stunning clouds of gas and dust, are the birthplaces of stars. But what if dark matter nebulae are doing something similar, except with forces we don't understand yet? Could they be shaping galaxies in ways we can't see? Could they be affecting space itself in ways that defy physics as we know it? The truth is, we have no way of directly observing dark matter nebulae, but the clues are there. Astronomers have found strange distortions in starlight, gravitational anomalies that don't make sense, and massive voids where something invisible seems to be exerting an incredible pull. These aren't just random observations. They could be evidence that dark matter nebulae are real. And if they are, it means we've been missing an entire layer of reality hiding in plain sight. To understand why this is such a big deal, let's go back to the basics of dark matter itself. Scientists estimate that about 85% of all matter in the universe is dark matter. That means everything we can see, stars, planets, galaxies, even our own bodies, makes up only a tiny fraction of what's really out there. But if dark matter is so dominant, why can't we see it? The reason is that it doesn't interact with light the way normal matter does. It doesn't reflect, emit, or absorb any light, making it completely invisible. The only way we even know it exists is because of its gravitational effects. It's like a ghost, exerting its presence without revealing itself. Now, imagine that instead of just being spread out evenly across space, dark matter is actually clumping together in enormous, invisible clouds. These would be dark matter nebulae, massive, unseen structures floating through the universe, shaping the cosmos without us even realizing it. Some scientists believe that these nebulae could be the missing link in our understanding of how galaxies form and evolve. In fact, they could be playing a role just as important as regular nebulae, but in a way that's completely beyond our current understanding of physics. Here's where it gets even more mind-blowing. Dark matter isn't just sitting there doing nothing. It's interacting with itself in ways we don't fully understand. Some theories suggest that dark matter particles might have their own kind of forces, different from the ones we know, which could allow them to clump together into these massive structures. If that's true, then dark matter nebulae could be more than just passive clouds of invisible matter. They could be dynamic, changing over time, influencing the galaxies around them in ways we've never considered. There's already some evidence that something strange is going on. When scientists look at the way galaxies rotate, they notice something odd. The outer edges of galaxies should be moving slower than the inner regions, but they're not. Instead, they're moving as if there's some invisible mass holding everything together. This is one of the biggest pieces of evidence for dark matter. But what if this unseen force isn't just spread out evenly? What if it's actually concentrated in vast, hidden nebulae, shaping galaxies from the shadows? And then there's gravitational lensing, the phenomenon where light from distant objects bends around an invisible mass. Astronomers have spotted countless examples of this, where something unseen is warping the fabric of space itself. In some cases, the distortions suggest that dark matter is forming structures more complex than just a smooth, uniform field. Some scientists believe that what we're seeing is the effect of dark matter clumping together, possibly even into nebulae. If these dark matter nebulae exist, they could be changing the way stars and galaxies form. Regular nebulae are made of gas and dust, providing the raw material for new stars. But dark matter nebulae could be influencing this process in a completely different way, through gravity alone. They might be acting like scaffolding, guiding the formation of galaxies and shaping the very structure of the universe. But here's where things get even stranger. If dark matter nebulae are real, then they could also be hiding something even more mysterious. Some scientists have speculated that dark matter might not just be some exotic, invisible substance. It could be linked to an entirely different form of physics, maybe even an alternate kind of matter that exists alongside our own. If that's the case, then dark matter nebulae might not just be clouds of invisible mass. They could be entire hidden realms of physics, operating under laws we don't yet understand. What's even more baffling is that we have no way of directly detecting these nebulae. We can only infer their existence from the way they warp space and affect the motion of galaxies. But some scientists are working on ways to indirectly study them. One approach involves looking for extremely rare interactions between dark matter and regular matter. If dark matter can occasionally interact with normal atoms in just the right way, then we might be able to catch a glimpse of it, giving us our first real evidence of dark matter nebulae. Another possibility is that dark matter nebulae could be influencing cosmic radiation in unexpected ways. Some researchers have suggested that high-energy particles coming from space might be interacting with dark matter in ways we don't fully understand yet. If we can detect unusual patterns in these cosmic rays, it could be another clue that dark matter nebulae are out there, shaping the universe in ways we never imagined. And then there's the question of how these nebulae formed in the first place. Did they arise naturally as the universe evolved? Or could they be the remnants of something even older and more mysterious? Maybe even something that predates the Big Bang? Some theories suggest that dark matter might have its origins in a time before our universe as we know it existed. If that's true, then dark matter nebulae could be more than just cosmic oddities. They could be ancient relics from an era that we can barely begin to comprehend. But perhaps the most mind-bending idea of all is that dark matter nebulae might not just be influencing galaxies. They could be affecting the very nature of space and time. Some scientists have proposed that dark matter could be linked to the fabric of the universe itself, acting as a kind of hidden structure that shapes the way space and time behave. If that's the case, then understanding dark matter nebulae could be the key to unlocking some of the deepest mysteries of physics, including the nature of gravity, the origins of the cosmos, and even the possibility of parallel universes. And if that's true, then we're only just beginning to scratch the surface of one of the greatest mysteries in the universe. If dark matter nebulae are real, they could be rewriting everything we think we know about the structure of the universe. They wouldn't just be passive clouds of invisible mass floating in space. They could be active participants in cosmic evolution, influencing how galaxies form, how stars are born, and maybe even how the laws of physics behave on the grandest scales. To understand just how important this is, let's take a step back and look at how regular nebulae shape the visible universe. In the simplest terms, nebulae are vast clouds of gas and dust where new stars are born. When enough matter gathers in one place, gravity takes over, pulling everything together until it collapses into a dense core that eventually ignites as a star. These nebulae are the cosmic nurseries of the universe, the places where planets, moons, and even life itself can eventually emerge. But now, imagine a version of this process happening with dark matter instead of normal matter. If dark matter can clump together into nebulae, then could it also form structures that mimic the role of traditional nebulae? Could these invisible clouds be shaping galaxies in ways we can't directly see, guiding the formation of stars, or even influencing the mysterious black holes at the centers of galaxies? Scientists have already noticed something strange happening around supermassive black holes. These objects, which sit at the heart of most galaxies, are far more massive than they should be if they formed from normal matter alone. Some researchers believe dark matter might be playing a hidden role, feeding these black holes in ways we don't yet understand. If dark matter nebulae exist, they could be supplying black holes with mass, acting as a sort of cosmic fuel that accelerates their growth. And if that's true, then dark matter nebulae might not just be influencing the formation of galaxies. They could also be linked to some of the most extreme phenomena in the universe, like quasars, gamma-ray bursts, and even the mysterious fast radio bursts that continue to baffle scientists. Another bizarre possibility is that dark matter nebulae could be interacting with dark energy, the equally mysterious force that's causing the universe to expand at an accelerating rate. Right now, we think of dark matter and dark energy as separate things. One pulls galaxies together with gravity, while the other pushes them apart. But what if they're actually connected? What if dark matter nebulae are acting as a bridge between these two cosmic forces, shaping the way the universe expands over time? If that's the case, then dark matter nebulae could be playing a far bigger role in cosmic history than anyone ever imagined. They might be the missing link between the universe's past and its future, helping to determine not just how galaxies evolve, but how the universe itself will ultimately end. But here's where things get even weirder. Some theories suggest that dark matter might not be made of just one kind of particle. Instead, it could be part of an entire hidden sector of physics, with its own types of matter, forces, and interactions. If that's true, then dark matter nebulae might not just be featureless clouds of mass. They could be rich, complex structures with their own internal dynamics, completely separate from the world we know. Imagine, for a moment, a reality where dark matter nebulae are more than just invisible clouds of particles. What if they have their own kind of chemistry, their own kinds of interactions, and maybe even their own hidden physics that we have no way of detecting yet? What if, within these vast, unseen nebulae, an entire parallel version of physics is playing out, one that exists alongside our own, but remains forever out of reach? It sounds like science fiction, but some of the latest research hints that something like this could be possible. Some scientists have proposed that dark matter might be capable of forming its own versions of atoms, held together by forces we haven't discovered yet. If that's true, then dark matter nebulae could be more than just cosmic oddities. They could be part of a hidden layer of reality, one that's been there all along, shaping the universe in ways we never realized. And if that's the case, then studying these nebulae might not just teach us about dark matter. It might reveal entirely new laws of physics, ones that could revolutionize our understanding of space, time, and the very nature of existence itself. But how do we even begin to detect something that, by definition, is invisible? Scientists are already exploring new ways to probe the mysteries of dark matter, using everything from underground detectors to powerful space telescopes. One promising approach is to look for tiny distortions in the cosmic microwave background, the faint glow of radiation left over from the Big Bang. If dark matter nebulae are real, then their gravitational influence might have left subtle fingerprints in this ancient light, providing us with a new way to study their properties. Another strategy involves looking for unusual signals in deep space. Some theories suggest that dark matter particles might occasionally interact with one another in ways that produce detectable bursts of radiation. If we can find these signals, we might be able to map out the locations of dark matter nebulae, revealing their shapes, sizes, and structures for the first time. But even if we do detect these nebulae, it raises another question. Could dark matter nebulae be influencing us in ways we don't even realize? After all, our own galaxy, the Milky Way, is surrounded by a vast halo of dark matter. If dark matter can form structures, then could there be dark matter nebulae right here in our cosmic backyard? Could they be affecting the motion of stars, the behavior of planets, or even the stability of our solar system in ways we've never considered? Some scientists have speculated that dark matter might be playing a role in the movement of comets and asteroids, subtly nudging their paths over time. Others have wondered whether dark matter could be influencing the way galaxies collide and merge, shaping cosmic events on an unimaginable scale. And if dark matter nebulae are real, they could be adding an entirely new layer of complexity to these already mysterious processes. But perhaps the most unsettling possibility is that dark matter nebulae might not be static. If dark matter has its own kind of physics, then these nebulae could be shifting, evolving, or even collapsing over time. What if dark matter nebulae can undergo their own version of star formation? What if they can collapse into dense, invisible objects, creating a hidden population of dark matter stars, black holes, or even stranger phenomena that we have no way of detecting? And what if, right now, as we speak, something is happening within one of these dark matter nebulae that could change the universe forever? If dark matter nebulae are evolving, shifting, or even collapsing into new structures, then we might be missing out on an entire side of cosmic evolution that's been happening in secret. Regular nebulae give birth to stars, which then shape the galaxies around them. But if dark matter nebulae can collapse into their own kinds of objects, then the hidden universe might be undergoing transformations that are just as dramatic as anything we can see with telescopes. Think about what that could mean. Right now, we assume that galaxies form in regions where dark matter has pulled together, creating a gravitational framework for normal matter to follow. But what if the reverse is also true? What if dark matter nebulae are reacting to the presence of galaxies, shifting their own structures in response to the changing universe around them? This could mean that dark matter isn't just passively sitting there, acting as an invisible scaffolding for normal matter. It could be dynamic, changing, and even influencing the way galaxies evolve over billions of years. If that's true, then dark matter nebulae could be some of the most important structures in the cosmos, vast, invisible networks that subtly control the fate of everything we see. But what would happen if one of these dark matter nebulae collapsed? If normal nebulae collapse, they ignite in massive bursts of energy, leading to the birth of new stars. Could dark matter nebulae be undergoing their own version of this process? Could they be collapsing into dark stars, dark planets, or even dark black holes, objects completely invisible to us, but still exerting a gravitational influence on the universe? Some theories suggest that dark matter might be capable of forming stable objects under the right conditions. These hypothetical dark stars wouldn't shine like normal stars, but they could still exist, held together by their own kind of physics. If dark matter nebulae are forming these structures, then they might not just be passive clouds of mass. They could be nurseries for an entire hidden world of dark matter objects that exist alongside our own, completely undetectable except through gravity. And here's where things get even more unsettling. If dark matter nebulae are capable of forming their own structures, then could they also be capable of destruction? Could there be some kind of dark matter supernova, an event where a dark matter nebula undergoes a catastrophic collapse, releasing energy in ways we don't yet understand? We've never seen anything like this before, but maybe that's because we haven't known where to look. If a dark matter nebula were to collapse, it might leave behind subtle clues in the fabric of space-time itself. It could create ripples in gravity, distort the orbits of nearby galaxies, or even send out faint signals that we've been mistaking for something else. And if that's true, then there's another question we have to ask: have dark matter nebulae ever influenced our own galaxy? Could one of these mysterious clouds have passed through the Milky Way at some point in the past, altering the motion of stars, disrupting planetary orbits, or even affecting life on Earth in ways we've never realized? Some scientists have speculated that periodic shifts in dark matter distribution could be responsible for strange events in the history of the solar system. Unusual asteroid impacts, sudden shifts in planetary climates, or even small anomalies in Earth's orbit might all be clues that something invisible has been moving through space, changing things in ways we can't explain. If dark matter nebulae are real, then they could be the missing link in understanding these mysteries. They might be the hidden force that has been shaping the universe from the very beginning, influencing galaxies, stars, and planets in ways we've never imagined. And if we can figure out how to detect them, we might finally start unlocking the deepest secrets of dark matter itself. But here's the biggest mystery of all: what if dark matter nebulae are more than just clouds of exotic particles? What if they represent something even stranger, something that doesn't fit within our current understanding of physics? Could they be linked to higher dimensions, acting as gateways to hidden aspects of reality that we can't perceive? Some researchers have suggested that dark matter might be connected to extra dimensions, existing not just in our three-dimensional space, but in ways that go beyond our comprehension. If that's the case, then dark matter nebulae might not just be part of our universe. They could be the shadows of something much larger, projections of structures that exist in a deeper layer of reality. And if that's true, then studying these nebulae might not just teach us about dark matter. It might give us our first glimpse of a hidden cosmos, a universe beyond our own, one that has been influencing us from the beginning without us even realizing it. What if, right now, dark matter nebulae are shaping the fate of the universe in ways we don't yet understand? What if they're not just cosmic oddities, but the key to unraveling the biggest questions in physics, astronomy, and even the nature of reality itself? And what if, somewhere out there, in the vast darkness of space, a dark matter nebula is shifting, collapsing, or evolving at this very moment, setting off a chain of events that could change the universe forever? If dark matter nebulae are truly evolving, shifting, or even collapsing, then we might be witnessing a fundamental process of the cosmos that has remained invisible to us for billions of years. But here's the real question. What would happen if one of these structures interacted with a galaxy in a way we could detect? We already know that dark matter plays a role in galaxy formation, acting as a kind of unseen framework that holds everything together. But what if dark matter nebulae are more than just passive clouds? What if they're actively influencing galaxies in ways we've never considered? Imagine a dark matter nebula drifting through intergalactic space, slowly approaching a galaxy like the Milky Way. Unlike regular nebulae, which are made of gas and dust, this structure would be composed of something completely alien, particles that barely interact with normal matter except through gravity. As it gets closer, its gravitational influence starts to pull on the stars at the edges of the galaxy, subtly changing their orbits. Over time, this invisible force could warp the shape of entire star systems, stretching and distorting them like a cosmic tide. And what if this process has already happened? Could the strange, warped shapes of some galaxies, like the twisted arms of irregular galaxies or the strange, elongated features of some spiral galaxies, be evidence of past encounters with these hidden nebulae? Astronomers have struggled to explain some of the odd structures we see in deep space. What if these anomalies aren't just the result of normal galactic interactions, but the lingering effects of dark matter nebulae passing through? But here's where things get even more mysterious. If dark matter nebulae can affect the structure of galaxies, could they also influence the formation of solar systems? We already suspect that dark matter plays a role in shaping cosmic structures on the largest scales, but what about on a smaller scale, like within a single star system? What if, billions of years ago, a dark matter nebula passed through the region of space where the solar system was forming? Could its gravitational presence have subtly influenced the arrangement of planets, determining why they ended up in their specific orbits? Could it explain some of the oddities in our own solar system, like why Uranus is tilted on its side or why Neptune's orbit is slightly different from what we would expect? And what if these nebulae still exist in our galaxy today? Could there be dark matter clouds drifting invisibly through the Milky Way, occasionally influencing planets, asteroids, or even space itself? Some scientists have speculated that the unexplained motions of certain celestial bodies, like the strange behaviors of distant Kuiper belt objects, or the odd orbits of some exoplanets, could be signs that something invisible is exerting gravitational influence. If that's the case, then the next question is even more unsettling. Could dark matter nebulae have an effect on Earth itself? It's easy to assume that because dark matter doesn't interact with normal matter in the way that gas or radiation does, it has no impact on our planet. But what if that's not entirely true? What if, in rare cases, dark matter nebulae can leave behind subtle traces, tiny anomalies that we haven't been able to explain? For example, could the presence of a dark matter nebula affect geological activity? Earth's core is a molten mass of metal, generating the magnetic field that protects our planet from solar radiation. But what if the gravity of a passing dark matter cloud could influence the flow of molten material deep beneath the surface? Could it explain sudden, unexplained shifts in the planet's magnetic field or even trigger increased volcanic activity? And here's an even more mind-bending thought. Could dark matter nebulae be affecting time itself? We already know that gravity has an effect on time. The stronger the gravitational field, the slower time moves, a phenomenon confirmed by Einstein's theory of relativity. If a massive dark matter nebula were to pass through our region of space, its gravitational pull could, in theory, slightly alter the flow of time in ways we wouldn't immediately notice. Imagine a scenario where a dark matter nebula passes near Earth, subtly warping the passage of time just enough to create tiny inconsistencies, small, imperceptible shifts that could accumulate over centuries or millennia. If this were happening, we might never notice it directly. Instead, we'd see it in strange, unexplained cosmic anomalies, clocks ticking slightly differently in deep space, spacecraft experiencing tiny deviations in their expected travel times, or even unexpected changes in the timing of astronomical events. And if this is possible, then it raises an even bigger question. Could dark matter nebulae be responsible for some of the greatest cosmic mysteries we've encountered? For example, some scientists have speculated that dark matter could be linked to the mysterious phenomenon of fast radio bursts, FRBs, intense, milliseconds-long bursts of radio waves that come from deep space with no clear explanation. Could these be signals from dark matter nebulae, created by interactions we don't yet understand? Or what about the strange motion of the Andromeda Galaxy, which is on a collision course with the Milky Way? We assume this is due to the normal gravitational pull of the two galaxies, but what if a hidden dark matter nebula is playing a role, pulling Andromeda toward us faster than we expected? And what if dark matter nebulae are part of something even bigger, a hidden cosmic cycle that we've never been able to detect? Right now, we think of the universe in terms of visible matter and dark matter, but what if there's a deeper interaction between the two? What if dark matter nebulae are the missing link between the formation of galaxies and the expansion of the universe? There are theories that suggest dark matter could be influencing cosmic expansion in ways we don't yet understand. The universe is not just expanding, it's accelerating. Something is driving this process, and we usually attribute it to dark energy. But what if dark matter nebulae are playing a role, subtly shaping the structure of the cosmos at a fundamental level? If that's true, then understanding these hidden nebulae could be the key to solving some of the biggest mysteries in physics. It could help us understand why the universe is expanding the way it is, why galaxies form in the patterns we see, and even whether our assumptions about the fundamental nature of reality are correct. And that brings us to perhaps the most intriguing question of all. Could dark matter nebulae be more than just physical structures? Could they be a key to understanding the deeper fabric of the universe itself? Some physicists believe that dark matter might be connected to higher dimensions, extra layers of reality that exist beyond our perception. If that's true, then dark matter nebulae might not just be floating clouds of invisible mass. They could be projections of something deeper, shadows of hidden structures that exist in a reality beyond our own. What if, right now, a massive dark matter nebula is passing through our galaxy, influencing the movement of stars, altering the flow of time, and affecting the universe in ways we can't yet detect? What if these structures are the missing pieces of the cosmic puzzle, the hidden forces that have been shaping reality from the very beginning? And what if, in the near future, we finally develop the technology to see them, to peer into the invisible universe and uncover a reality far stranger than anything we ever imagined? Because if dark matter nebulae are real, then they might not just be the biggest mystery in space. They might be the key to understanding the true nature of existence itself. If dark matter nebulae are indeed the missing puzzle pieces in our understanding of the universe, then their implications extend far beyond just astronomy. They could redefine how we think about physics itself. For decades, physicists have been searching for a unified theory that can explain everything from the behavior of subatomic particles to the vast structure of the cosmos. Dark matter nebulae might hold the answers we've been looking for, not just in the form of invisible mass but as a fundamental force that connects the very fabric of reality. But to fully grasp what that means, we need to ask an even deeper question: what is dark matter really? For years, the leading theory has been that dark matter consists of exotic, weakly interacting particles, perhaps something like WIMPs, weakly interacting massive particles, or axions, both of which have been theorized but never directly observed. But what if dark matter nebulae are not made of particles at all? What if they are something stranger, something we've never even considered? One mind-blowing possibility is that dark matter nebulae are actually composed of microscopic black holes, tiny, primordial remnants from the earliest moments of the universe. Some theories suggest that shortly after the Big Bang, high-energy conditions could have created minuscule black holes, too small to be detected by current technology, but still massive enough to exert a gravitational pull. If true, dark matter nebulae might be vast clouds of these micro-black holes, clustering together in ways that mimic the behavior of ordinary gas clouds. And if that's the case, then the implications are staggering. Because unlike ordinary matter, black holes distort the very fabric of space and time. If a dark matter nebula were made up of countless tiny black holes, it wouldn't just influence the motion of galaxies. It could be warping spacetime itself on a scale we've never considered before. But there's an even weirder possibility. What if dark matter nebulae are not physical structures in the traditional sense? What if they exist as fluctuations in spacetime, ripples in the underlying energy of the universe that only manifest gravitationally? Some physicists have proposed that dark matter might be a byproduct of quantum gravity, the elusive theory that aims to merge general relativity with quantum mechanics. In this view, dark matter nebulae wouldn't be things in the way we normally think of them. Instead, they would be zones of altered spacetime, where the rules of physics behave differently than anywhere else. If that's true, then encountering a dark matter nebula wouldn't just mean experiencing an invisible gravitational pull. It could mean stepping into an entirely different realm of physics, one where time slows, matter behaves unpredictably, and the very laws of nature shift in ways we can't yet understand. And here's where things get truly unsettling. If dark matter nebulae are capable of warping spacetime, could they be linked to the strange distortions we've detected throughout the cosmos? For instance, astronomers have observed bizarre gravitational anomalies, places where light bends in unexpected ways, or where the movements of stars and galaxies seem to defy known physics. Could these be signs that dark matter nebulae are lurking nearby, bending the universe itself in ways we're only beginning to grasp? And if these structures are distorting spacetime, could they also serve as natural accelerators for particles? In recent years, scientists have detected cosmic rays, high-energy particles that slam into Earth from deep space, with energies that seem almost impossible to explain. Some of these cosmic rays are so powerful that they defy the limits of known astrophysical sources. Could dark matter nebulae be acting as invisible particle accelerators, hurling high-energy radiation across the universe in ways we never predicted? But let's take this idea one step further. If dark matter nebulae can bend space and time, could they also serve as gateways? Some physicists have speculated that certain extreme gravitational environments, like the edges of black holes, might allow for the formation of wormholes, hypothetical tunnels through spacetime that could connect distant parts of the universe. If dark matter nebulae have similar gravitational effects, could they be creating hidden pathways across the cosmos, wormholes that exist right under our noses, but remain invisible because they're made of dark matter? And if that's the case, then it raises the ultimate question: could something be using these nebulae to travel? Could there be unknown civilizations, far older and more advanced than we can imagine, that have already discovered the secrets of dark matter, harnessing these structures as cosmic highways? If dark matter nebulae can distort space, then a sufficiently advanced species might not need traditional spacecraft at all. Instead, they could use these hidden structures to navigate the universe in ways that completely defy our understanding. What if UFO sightings or unexplained celestial anomalies aren't just coincidences? What if, every once in a while, we're catching glimpses of something passing through these dark matter corridors, something that isn't bound by the same physical laws that we are? And if that idea sounds too far-fetched, consider this. We already suspect that our own solar system is moving through a vast dark matter halo. If there are dense pockets of dark matter within that halo, hidden nebulae drifting through interstellar space, then it's possible that Earth itself has encountered them before. Could certain unexplained historical events, like strange gravitational disturbances or unexplained shifts in planetary orbits, be evidence that a dark matter nebula has passed through our region of space? And here's one final, chilling thought: if dark matter nebulae are real, and they are constantly shifting and evolving, then we have no idea where the next one might be. There could be a massive, invisible structure drifting toward our solar system right now, completely undetectable by our current technology. And one day, we might suddenly feel its presence, not as a visible object, but as a strange and subtle shift in reality itself. What if the greatest cosmic event in human history isn't a supernova, a gamma-ray burst, or a collision of galaxies? What if, instead, it's the slow, silent arrival of an invisible force that has been shaping the universe since the beginning, one that we are only now starting to comprehend? And when that moment comes, will we be ready to understand what it means? Or will we be left staring into the darkness, wondering what's really out there? The thought of a dark matter nebula silently drifting toward us is unsettling. Unlike a rogue planet or a wandering black hole, it wouldn't announce its presence with visible light or radiation. It would be an invisible force, warping the very structure of reality without us even realizing it, until something strange happened. Imagine the unexplained shifts we might notice, the orbits of planets subtly changing, the trajectories of asteroids bending in ways that don't match our models, or spacecraft experiencing slight but persistent deviations from their planned courses. At first, these changes might be dismissed as anomalies, quirks in the data. But as they accumulated, scientists would begin to suspect that something enormous, and unseen, was at work. And here's where things get even stranger. If dark matter nebulae are capable of warping space-time, then they could affect more than just gravity. They could influence time itself. We already know that strong gravitational fields can slow down time, as seen in extreme environments like black holes. But what if a dark matter nebula could produce a similar effect? What if, as Earth moved through one of these invisible clouds, time itself started behaving differently? What would that look like? Imagine clocks on Earth running slightly slower compared to those in orbit, not because of any known relativistic effect, but due to the influence of an unseen gravitational force. Imagine strange discrepancies in astronomical observations, stars appearing to shift positions in ways that defy physics, or pulsars ticking at inconsistent rates. Could certain historical anomalies, mysterious disappearances, unexplained distortions in satellite signals, or even odd fluctuations in the global positioning system, be signs that we've unknowingly passed through a region of altered space-time? Some scientists have even speculated that dark matter could interact with the human brain in subtle ways. The idea may sound outlandish, but consider this: the brain operates using electrical impulses, and electricity is influenced by electromagnetic fields. If dark matter isn't completely inert, if it has even the slightest ability to interact with forces beyond gravity, could it be affecting the way neurons fire? Could certain unexplained mental phenomena, like sudden flashes of insight, unexplained premonitions, or even the feeling of being watched, have a hidden cosmic origin? And if dark matter nebulae are drifting through space, interacting with different regions of the galaxy over billions of years, then what effect might they have had on the evolution of life itself? Could the development of intelligence, our ability to think, reason, and dream, have been subtly shaped by encounters with these invisible structures? Could the very nature of consciousness be tied, in some unknown way, to the hidden forces of the universe? If that's the case, then dark matter nebulae aren't just cosmic mysteries. They could be the missing link between the physical universe and the deepest questions of existence. What if they are the reason we look up at the stars and wonder? What if, without even realizing it, we've always been reaching for something we can't see, something that has been shaping us from the beginning? And if that's true, then what happens when we finally uncover the truth? What happens when we develop the technology to see beyond the limits of our current understanding? What happens when we realize that the universe isn't just made of what we can detect, but also of vast, hidden structures that have been influencing everything from the motion of galaxies to the very way we think? One day, we might build instruments sensitive enough to detect dark matter nebulae directly. One day, we might send a probe into one of these invisible structures and watch as it disappears into an unknown realm of physics. And one day, we might finally understand what these enigmatic clouds really are, not just as cosmic mysteries, but as fundamental pieces of the universe that have been with us all along. But until then, we can only speculate, watch, and wait. Because somewhere out there, in the darkness between the stars, something unseen is moving. And whether we're ready or not, it may already be on its way. If a dark matter nebula were truly drifting toward us, or worse, if we were already inside one, how would we even begin to detect it? The challenge is immense. Traditional telescopes rely on light, radio waves, or other forms of electromagnetic radiation, all of which dark matter ignores completely. No glow, no reflection, no shadow. But just because we can't see it doesn't mean we're powerless to find it. Scientists are developing new ways to indirectly observe dark matter, using gravitational lensing, the bending of light caused by massive objects, to infer its presence. If a dark matter nebula were nearby, we might see distant stars and galaxies subtly shifting in ways that don't match any known mass in the area. But even then, the effect would be slight, requiring incredibly precise instruments and years of observation to confirm. However, there's another, more dramatic way we might detect a dark matter nebula: by watching for disturbances within our own solar system. The planets follow highly predictable orbits, governed by Newton's laws of motion and Einstein's theory of gravity. Any deviation, no matter how small, would be a red flag. If, for example, Mars began drifting slightly off its expected path, or if asteroids in the Kuiper belt started behaving erratically, it could be evidence that an invisible mass, something vast and unaccounted for, was exerting a gravitational pull. And what if the effects weren't limited to space? What if Earth itself began experiencing unexplained phenomena? Our planet moves through space at roughly 67,000 miles per hour, orbiting the Sun while also hurtling through the Milky Way. If we pass through a dense region of dark matter, could it cause subtle but measurable changes in Earth's rotation, altering the length of our days by fractions of a second? Could it affect the tides, shifting the behavior of our oceans in ways that defy prediction? Even more unsettling, could it influence life on Earth? We often think of evolution as driven purely by natural selection and environmental pressures. But what if there's another factor, something deeper, something cosmic? If dark matter nebulae subtly warp the fabric of reality, could they also play a role in genetic mutations, the very foundation of evolutionary change? Could life as we know it be shaped not just by the visible universe, but by the unseen forces that have been flowing through it for billions of years? And here's the most mind-bending thought of all. If dark matter nebulae exist, and if they have been affecting the universe since its infancy, then could they also serve as natural records of cosmic history? Unlike stars and planets, which form, evolve, and eventually die, dark matter is thought to be nearly indestructible. A nebula made of dark matter might be as old as the universe itself, untouched by the forces that have shaped and reshaped everything else. It could contain imprints, gravitational echoes, of events that happened billions of years ago, long before Earth even existed. Imagine if we could somehow decode those imprints, extracting a hidden history of the cosmos. What secrets might be locked within these ghostly structures? Could they reveal the moments just after the Big Bang, when the universe was still a chaotic sea of energy? Could they hold traces of ancient, long-extinct civilizations, evidence of intelligent beings who came before us, their presence recorded not in ruins or artifacts, but in the very fabric of space itself? And if that's true, then dark matter nebulae aren't just cosmic mysteries. They are time capsules, drifting through the universe, carrying secrets beyond our wildest imagination. They are both the past and the future, silent witnesses to everything that has ever been, and everything that ever will be. The question is, when we finally learn how to listen, what will they tell us? If dark matter nebulae are time capsules, drifting through the universe with imprints of the past woven into their structure, then understanding them could revolutionize how we see reality itself. But how would we even begin to decode them? What tools would we need to extract hidden information from something invisible? And more importantly, could interacting with dark matter nebulae alter the very fabric of time and space in ways we can't yet predict? One of the most promising ways to study dark matter nebulae is through gravitational wave detectors. These highly sensitive instruments, like LIGO and Virgo, can pick up incredibly tiny ripples in space-time caused by massive cosmic events, things like black hole mergers or neutron-star collisions. If a dark matter nebula passed through our solar system, could it generate gravitational waves different from anything we've observed before? Could it create subtle distortions in spacetime that leave behind signatures we don't yet recognize? Imagine an advanced version of LIGO capable of detecting not just massive cataclysms, but also the faintest whispers of gravitational disturbances. If a dark matter nebula has been influencing the universe for billions of years, then it might carry a kind of cosmic fingerprint, a distortion pattern unlike anything caused by ordinary matter. And if we could detect that fingerprint, we might finally have a way to see the invisible. But what if we could go further than just detecting a dark matter nebula? What if we could physically interact with it? This idea seems impossible at first. Dark matter is famously elusive, refusing to interact with normal matter except through gravity. But there's a growing possibility that dark matter might not be completely passive. Some theories suggest it could interact with itself in ways we don't yet understand, forming structures, clumps, or even entire networks of dark matter filaments stretching across the universe. If a dark matter nebula is more than just a random cloud, If it has internal structure, then could we send a probe into it? Could we engineer a spacecraft designed to detect the faintest gravitational fluctuations, capable of navigating an ocean of unseen forces? What would happen if we passed an object through a dense region of dark matter? Would it experience resistance, as if moving through a thick fog? Would time itself behave differently within the nebula's boundaries? Some researchers speculate that dark matter could even act as a kind of cosmic veil, obscuring parts of reality from our view. If that's the case, then dark matter nebulae might be more than just invisible clouds. They could be barriers between different states of existence. Could passing through one open a door to a hidden aspect of the universe? Could they be natural gateways to unexplored dimensions? This brings us to a truly mind-bending possibility. If dark matter nebulae distort space-time, could they create pathways through the cosmos? The idea of wormholes, shortcuts through space-time, has fascinated scientists for decades, but no natural examples have ever been found. But what if they've been hiding in plain sight all along, disguised as massive, invisible structures? What if dark matter nebulae aren't just passive clouds of unknown mass, but active conduits that bend the rules of physics in ways we can't yet comprehend? Imagine if a civilization far more advanced than ours had already figured this out. If they had learned to harness dark matter nebulae, to navigate through them, or even to manipulate their structure, they might have access to a cosmic highway system completely undetectable to us. Could this explain some of the anomalies we've observed in deep space, strange disappearances of stars, unexplained bursts of energy, or gravitational shifts with no apparent cause? Could an advanced intelligence be using dark matter nebulae as intergalactic travel corridors, slipping through reality while remaining completely invisible to us? And if that's the case, then what happens when we finally gain the ability to see what's been hidden all along? If dark matter nebulae are more than just drifting cosmic ghosts, if they are actively shaping reality in ways we don't yet understand, then our ignorance of them is one of the greatest blind spots in modern science. Think about it. We have mapped galaxies billions of light years away, we have detected exoplanets orbiting distant stars, and we have even taken a direct image of a black hole's event horizon. But we are still unable to explain what makes up the majority of the universe. If dark matter nebulae are real, then they could be not only the key to understanding dark matter itself but also a missing piece in our fundamental understanding of the cosmos. Consider the idea that dark matter nebulae are not static but dynamic, flowing like cosmic rivers, shifting under the influence of gravity, and even colliding with one another in ways we can't yet observe. If dark matter behaves anything like regular matter, then these nebulae might have internal currents, dense regions, and even chaotic turbulence similar to how air moves through a storm or water moves through the deep ocean. But if we can't see or feel these structures, how would we ever confirm their presence? The answer might lie in one of the most unusual forces in physics: quantum interactions. There is a growing belief among some physicists that dark matter may interact with itself through a force that has not yet been detected, sometimes referred to as a dark force. If such a force exists, it would mean that dark matter is not just a passive gravitational player but a complex, evolving substance with its own laws of motion. A dark matter nebula, then, wouldn't just be a static, ghostly cloud. It could be a swirling, dynamic entity, changing shape over time, forming patterns, and perhaps even responding to forces we don't yet understand. Could it be possible that these nebulae create large-scale structures within the universe, influencing the formation of galaxies, or even acting as gravitational anchors for entire clusters of stars? And if dark matter interacts with itself, could it also interact, however weakly, with normal matter? This is where things get even stranger. Some physicists have proposed that dark matter might be able to scatter or weakly interact with atomic nuclei, creating rare but potentially detectable effects. If a dark matter nebula drifted through our solar system, could it cause unexplained fluctuations in highly sensitive instruments, like atomic clocks or superconducting sensors? Could it influence the way particles behave at the quantum level, creating anomalies in physics experiments that we currently dismiss as experimental errors? More intriguingly, could the presence of a dark matter nebula affect the human body? While there is no current evidence that dark matter interacts with biological matter in any noticeable way, the possibility cannot be ruled out entirely. If dark matter carries its own forces, could it subtly influence chemical reactions, cellular processes, or even neurological activity? Some speculative theories suggest that the brain's most fundamental processes, such as consciousness itself, may have quantum components. If dark matter can interact at the quantum level, then could the presence of a dark matter nebula alter the way our minds perceive reality? And then there is the question of what dark matter nebulae could mean for the future. If these structures are drifting through the cosmos, then they must have trajectories, paths that they follow under the influence of gravity. Could it be that some of these nebulae are headed straight for us? Imagine a future in which astronomers detect a massive, invisible mass approaching the solar system, one that doesn't emit light but exerts an undeniable gravitational pull. What would happen if Earth were to pass directly through such a structure? Would we notice anything at all? Would there be subtle shifts in gravity? Could time itself behave differently inside a dark matter nebula, stretching or compressing in ways that defy everything we thought we knew about physics? And the biggest question of all, if dark matter nebulae are a fundamental part of the cosmos, then what else is lurking in the unseen? Could there be entire dark matter planets, dark matter stars, or even entire dark matter galaxies hiding right next to us, completely undetectable except through their gravitational influence? Could it be that the universe we see, the one made of stars, planets, and galaxies, is only a fraction of what truly exists? If we ever develop the technology to directly study dark matter nebulae, it could change everything. It could reveal new physics, uncover hidden dimensions of reality, and perhaps even lead to technologies that allow us to manipulate gravity itself. It could prove that the universe is far stranger than we ever imagined, and that we are only just beginning to scratch the surface of the greatest cosmic mystery of all time. If dark matter nebulae are more than just cosmic shadows, if they are actively shaping the universe in ways we can't yet measure, then the implications stretch far beyond astrophysics. They could redefine our understanding of existence itself. Imagine a universe where entire structures, possibly even entire civilizations, exist within a framework we cannot see. If dark matter forms vast, complex networks that influence the motion of galaxies, could it also support stable formations, planets, ecosystems, or even life? Could there be an entire realm of existence hidden within these invisible nebulae, just beyond the reach of our senses? One of the biggest obstacles to answering these questions is that our current scientific instruments are designed to study visible matter. Telescopes detect electromagnetic radiation, light, radio waves, X-rays, gamma rays. But dark matter doesn't emit or absorb light. It's like trying to study the wind without being able to see air move through the sky. Scientists have developed indirect methods, like tracking gravitational lensing, the bending of light caused by unseen mass. But this only provides a rough idea of where dark matter might be concentrated. If a dark matter nebula passed through our solar system right now, we wouldn't even know unless it caused measurable distortions in the orbits of planets. But what if we could develop instruments specifically designed to detect dark matter interactions? One possibility is using quantum sensors, ultra-sensitive devices that can pick up tiny fluctuations in physical forces. These sensors rely on the principles of quantum mechanics to measure gravitational changes at an almost imperceptible level. If a dark matter nebula passed through Earth, could it cause tiny changes in gravity that could be picked up by such sensors? Could it create shifts in the behavior of fundamental particles, revealing itself through unexplained anomalies? Some researchers believe that by placing quantum sensors in deep space, far from the noise of Earth's environment, we could begin to detect the presence of dark matter structures in real time. But there's another approach that could be even more revolutionary: direct interaction. If dark matter nebulae exist, then they may not be entirely separate from the world we know. Some theories suggest that dark matter could interact with normal matter under extreme conditions, such as within the cores of neutron stars or inside black holes. If that's the case, then the key to unlocking dark matter's mysteries might lie in studying the most extreme environments in the universe. Could it be that black holes don't just consume normal matter, but also influence the behavior of dark matter, creating hidden structures we've never detected? Could dark matter nebulae act as reservoirs of gravitational energy, slowly feeding into black holes and influencing their growth over billions of years? And if dark matter nebulae interact with black holes, what happens at the event horizon, the point of no return where matter and energy are forever trapped? Some radical theories suggest that dark matter might not experience black holes the same way regular matter does. Instead of being consumed, it might pass through or even accumulate in ways we don't yet understand. Could dark matter nebulae be the missing link in explaining why black holes behave the way they do? Could they be responsible for some of the unexplained phenomena surrounding these cosmic giants, such as the mysterious jets of energy that shoot from their poles, or the strange way some black holes seem to grow faster than expected? If we could one day create an experiment capable of manipulating dark matter, the implications would be staggering. We could unlock new forms of energy, revolutionizing space travel and allowing us to harness gravity in ways never before imagined. We could finally determine whether dark matter carries hidden forces, possibly leading to the discovery of a fifth fundamental force of nature beyond gravity, electromagnetism, and the nuclear forces. And if dark matter nebulae are connected to the deepest structures of reality, we might even uncover secrets about the fundamental nature of time itself. What if dark matter nebulae don't just exist in our universe, but also act as bridges to others? Some physicists propose that dark matter could be a remnant of another dimension, something that coexists with our reality, but remains hidden from view. Could dark matter nebulae be remnants of a previous universe, a ghostly imprint left behind after the last cosmic cycle? Could they be echoes of a parallel reality, where physics operates under an entirely different set of rules? If we could enter a dark matter nebula, would we experience time differently? Would the laws of physics shift? Could these nebulae be natural portals, not just across space, but across realities? And if that's true, then we must ask the most profound question of all: are we alone in the universe, or have we simply been looking in the wrong place? If dark matter nebulae form structures that we can't see, then is it possible that intelligent life exists within them? Could entire civilizations be thriving in a dark matter-based reality, moving through the cosmos undetected by our instruments? Could they have already discovered us, studying our world from a perspective we can't even comprehend? If dark matter holds the key to a hidden side of the universe, then the search for extraterrestrial life might not be about scanning distant stars. It might be about finding a way to perceive the unseen. But perhaps the most unsettling possibility is that dark matter nebulae are more than just passive structures drifting through the void. What if they are alive? Not in the way we understand life, not biological, not carbon-based, but as something entirely different. If dark matter has its own forces, its own form of organization, then could it possess a kind of intelligence beyond anything we can grasp? Could these nebulae be vast, conscious entities, beings that exist outside the limits of normal matter, perceiving the universe in ways beyond our comprehension? If that's the case, then what happens when we finally develop the ability to interact with them? Would they acknowledge us? Would they respond? Would they see us as primitive beings, struggling to grasp the true nature of existence? And the final, most terrifying question: what if they already have? If dark matter nebulae are more than just inert clouds drifting through the void, if they possess structure, influence, or even intelligence, then everything we think we know about the universe might be incomplete. It raises a fundamental question: what if these vast, unseen structures are actively shaping the cosmos in ways we haven't yet realized? Consider this: we already know that dark matter makes up the majority of mass in the universe, and that it interacts with gravity. That means it's not just sitting there doing nothing. It's exerting force. It's shaping galaxies, bending light, and potentially forming structures we haven't yet observed. But what if the way we think about dark matter is completely wrong? What if we're missing something crucial because we're only looking at reality through the narrow lens of visible matter? For decades, scientists have tried to explain dark matter as a simple, passive element, something that merely exists, providing the extra gravitational pull necessary to hold galaxies together. But what if it's more than that? What if dark matter isn't just a substance, but a framework, an entire hidden infrastructure of the cosmos that we've only glimpsed in distorted shadows? And what if these dark matter nebulae are more than just regions of higher density? What if they are the scaffolding of reality itself? Imagine a universe where dark matter nebulae aren't just passive clouds but active, dynamic regions that influence the formation of stars, galaxies, and even black holes. Some physicists have proposed that dark matter might have its own set of forces, interactions we haven't discovered yet. If that's true, then dark matter nebulae could be forming structures parallel to the ones we see in normal matter. They might contain filaments, clusters, or even vast, invisible landscapes stretching across billions of light years. And here's the most mind-bending part. If dark matter has forces of its own, then those forces might be capable of doing things normal matter cannot. Think about how ordinary matter behaves. It clumps together under gravity, forming stars, planets, and galaxies. But dark matter doesn't interact with light, meaning it doesn't form structures in the same way. So how do dark matter nebulae take shape? Are they bound by a different kind of force, one we can't detect because we've never had the right tools to measure it? Could they be held together by exotic physics, existing in a state that defies everything we understand? Some scientists have proposed that dark matter might be influenced by an unknown, hidden force, something beyond the four fundamental forces we currently recognize. If that's the case, then dark matter nebulae could be operating under an entirely different set of physical laws. They might experience gravity differently, forming structures that don't follow the same rules as normal galaxies. Imagine looking at the universe and realizing that half of it operates under a completely separate set of principles. It would mean that our entire understanding of physics is only half complete. And if dark matter nebulae are governed by different laws, then the implications are staggering. It could mean that there are entire cosmic structures hidden within them, galaxies, planets, even life, that exist outside our current understanding. What if dark matter nebulae are vast, invisible realms where an entirely different form of physics allows for exotic types of existence? Could there be dark matter planets orbiting dark matter stars, completely undetectable to us because they don't emit light? Could there be civilizations, even entire galaxies, thriving in a hidden reality that coexists with our own? Now, here's where things get even stranger. Some researchers have suggested that dark matter might not be entirely separate from normal matter. There could be rare conditions under which the two interact. If that's true, then dark matter nebulae might not just be isolated from us. They might be subtly influencing the world we see. What if dark matter nebulae affect time, bending it in ways we don't yet understand? Could they be responsible for unexplained cosmic anomalies, places where the laws of physics seem to break down? Could they create pockets of warped space, regions where gravity behaves unpredictably, or where time flows differently? And here's the most unsettling possibility. What if we've already encountered dark matter nebulae without realizing it? There are places in the universe where strange things happen, regions where galaxies behave in inexplicable ways, where the expansion of space itself seems inconsistent. Could these anomalies be caused by massive, hidden structures made of dark matter? Could dark matter nebulae be acting as gravitational lenses, distorting light and altering the very fabric of reality around them? But there's another, even more bizarre theory, one that challenges everything we think we know. Some scientists have proposed that dark matter might be a remnant of a previous universe. If that's true, then dark matter nebulae could be the lingering imprint of cosmic structures that existed before the Big Bang. Imagine a reality where entire galaxies once thrived, only to collapse and dissolve into an invisible substance that now drifts through our universe as a ghostly echo of what once was. Could dark matter nebulae be the last remnants of an ancient cosmos, the leftovers of a time before time itself? If that's the case, then what does it mean for us? Are we just the latest iteration of existence, built on the remnants of a forgotten past? Could dark matter nebulae be the missing link connecting us to an older, hidden history of the cosmos? And if we could unlock their secrets, could we uncover knowledge about the origins of everything, not just our universe, but the very nature of existence itself? These questions lead to an even more mind-blowing idea. What if dark matter nebulae aren't just passive remnants, but active gateways? Some theories in quantum physics suggest that the fabric of reality isn't fixed, that there may be ways to move between different states of existence. If dark matter nebulae contain properties that we don't yet understand, could they be natural bridges between different dimensions? Could they be pathways to parallel realities, cosmic tunnels that connect distant points in space, or even different universes? If that's true, then the implications are beyond anything we've ever imagined. It would mean that dark matter nebulae aren't just a mystery to be solved, they are a doorway to something far greater. They could hold the key to interstellar travel, to understanding the nature of consciousness, or even to unlocking the secrets of time itself. And if dark matter nebulae are gateways, then we have to ask the most important question of all: has anyone, already traveled through them? If dark matter represents an unknown form of reality, then could something exist on the other side? Could there be beings, intelligences, who exist not in our visible universe, but within the dark matter structures that permeate all of space? Have they been watching us, waiting for the moment when we finally develop the ability to perceive them? And if we do, will we be ready for what we find? If dark matter nebulae are more than just hidden clouds of unseen mass, if they are active structures that interact with the fabric of the universe in ways we don't yet understand, then the reality we perceive is only a fraction of the full cosmic picture. Imagine for a moment that we've been looking at the universe as if through a keyhole, seeing only the portion of reality that interacts with light. What if beyond that keyhole lies an entire world we've never even begun to grasp? What if dark matter nebulae are shaping not just the movement of galaxies, but the very structure of time and space itself? One of the most intriguing aspects of dark matter is its gravitational influence. We know that dark matter can bend light, causing the phenomenon known as gravitational lensing. This means that dark matter nebulae could be acting as massive cosmic magnifying glasses, distorting the images of distant galaxies and warping the appearance of space itself. But what if this effect is more than just an optical illusion? What if dark matter nebulae are actually altering the way time and space flow? Some physicists have proposed that dark matter might be linked to exotic forms of gravity, variations in space-time curvature that go beyond Einstein's equations. If that's true, then dark matter nebulae might not just be passive clouds. They could be cosmic engines, influencing the movement of entire star systems. They could be creating invisible highways through space, pathways where gravity behaves in unexpected ways. Could these hidden corridors explain the strange, seemingly impossible motions of some celestial objects? Consider the bizarre case of stars and galaxies that appear to be moving faster than they should be. Traditional physics tells us that as galaxies rotate, their outer edges should move more slowly than their centers, just like the way planets orbiting the sun slow down as they move farther away. But that's not what we observe. Instead, galaxies rotate almost as if they were solid disks, with stars on the outskirts moving just as fast as those near the center. The explanation? Dark matter. But what if the way dark matter behaves isn't as simple as just adding extra gravity? What if dark matter nebulae are creating unseen forces that accelerate objects in ways we haven't yet discovered? Now, let's push this idea even further. If dark matter nebulae are influencing motion on a galactic scale, could they also be affecting reality on a smaller scale? Could they be responsible for the strange distortions in physics that we sometimes observe, such as quantum anomalies or unexplained shifts in the structure of space-time? What if dark matter nebulae are acting as cosmic stabilizers, preventing the universe from unraveling? Or, even more unsettling, what if they're not just stabilizing forces, but active participants in cosmic evolution? There's an idea in theoretical physics that suggests dark matter might interact with itself in ways we haven't yet detected. If that's true, then dark matter nebulae might not be uniform, passive structures, but dynamic, evolving entities. They might shift and change over time, growing, merging, or even decaying like ordinary matter does. Could they be undergoing processes that we've never observed, dark matter star formation, dark matter supernovae, or even dark matter galaxies forming within them? If that's the case, then our entire concept of what constitutes a nebula could be wrong. We think of nebulae as vast clouds of gas and dust, regions where stars are born. But if dark matter nebulae are undergoing their own mysterious processes, then they could be birthing structures we can't even see. Imagine an entire ecosystem of dark matter formations, something as intricate and diverse as the galaxies we observe, but completely invisible to us. And if dark matter nebulae are places where new structures are forming, then we have to ask a bigger question. Are they creating something alive? This leads to one of the most mind-blowing possibilities: the idea that dark matter nebulae could be home to a completely different kind of life. Life as we know it depends on normal matter, on interactions between atoms and molecules that follow the rules of chemistry and physics. But if dark matter operates under different laws, then could it support an entirely new form of biology? What if, hidden within dark matter nebulae, there are entities, creatures, civilizations, even entire ecosystems, that exist beyond the reach of our current understanding? What if they have developed intelligence, technology, or even a way to observe us, even though we can't observe them? Could dark matter nebulae be the habitats of beings that exist in a parallel form of reality? Beings who have evolved in conditions that are fundamentally different from our own? And here's the real question: if these beings exist, do they know about us? If dark matter nebulae are shaping the universe in ways we don't yet understand, then we might be nothing more than an anomaly in their world, just as they are an anomaly in ours. But what if there is a way for our two realities to intersect? Some physicists have speculated that under extreme conditions, dark matter and ordinary matter might be able to interact. Could there be rare moments where the veil between these two realms is lifted? Have there been events in history, cosmic anomalies, unexplained occurrences, that could be evidence of such an interaction? Or, even more unsettling, are we the ones intruding into their reality? If our universe is expanding and changing, then could it be that our reality is colliding with dark matter structures in ways that we don't yet comprehend? Could our future hold a moment where dark matter nebulae become more than just mysterious shadows, where they become gateways to something far beyond our current knowledge? And if that moment comes, will we be ready to face what lies beyond the darkness? If dark matter nebulae are not just passive structures but active, evolving formations in the universe, then we may be on the brink of a discovery that changes everything we think we know about physics, cosmology, and even existence itself. The implications are staggering. If these vast, invisible clouds of dark matter are more than just gravitational wells holding galaxies together, if they have their own internal dynamics, then what else could they be hiding? Could they be reservoirs of an unknown form of energy? Could they be remnants of a previous universe, echoing across the fabric of space-time? One of the biggest questions in physics is whether dark matter interacts with itself. We already know that it doesn't interact with normal matter through electromagnetic forces, which is why we can't see it, but what if it has its own set of forces that we've never detected? Some scientists have speculated about the existence of a dark sector, a whole set of unknown particles that interact with each other through forces that don't affect normal matter. If this is true, then dark matter nebulae could be more than just empty clouds. They could be dynamic structures, evolving and changing over time, governed by forces that exist completely outside our current understanding. Imagine a scenario where dark matter nebulae undergo their own kind of cosmic weather, with invisible storms raging across vast distances. Just as we see turbulence in interstellar gas clouds, could there be turbulence in these unseen nebulae? Could there be currents, vortexes, or even waves propagating through them, creating unseen but powerful effects on the surrounding universe? What if these fluctuations in dark matter density are responsible for some of the unexplained anomalies we've observed in deep space? There have been cases where galaxies appear to be moving in ways that make no sense. Some galaxies seem to be accelerating toward unseen points in space, as if something massive is pulling on them, but there's nothing visible there. Could these be effects caused by shifting dark matter nebulae? What if these massive structures are drifting, merging, or even colliding with each other in ways that subtly but profoundly alter the cosmos? Now, let's take this idea even further. If dark matter nebulae have their own internal structures, then could they be home to something even more astonishing? Could they contain unknown forms of matter or energy that have never been detected before? There's a long-standing mystery in physics about the missing mass of the universe. We know that dark matter makes up most of the universe's mass, but there's still something missing, something unaccounted for. Could the answer lie in these vast, invisible clouds? Could they be hiding something even stranger than dark matter itself? Some theorists have proposed that dark matter might not be a single type of particle but an entire hidden ecosystem of different kinds of matter, interacting in ways we've never imagined. If that's the case, then dark matter nebulae might not just be empty clouds but active regions where new forms of physics are at play. Could they be the birthplace of exotic particles, forming and decaying in ways we've never observed? Could they be regions where unknown quantum effects are amplified on a cosmic scale, creating phenomena we can barely begin to comprehend? And if these nebulae are more than just clouds, if they are structured in some way, then what could they look like? Could there be layers, densities, or even unseen storms within them? Could they have cores, like the dense centers of galaxies, or be shaped by hidden gravitational forces? And if they are evolving over time, could they eventually give rise to something even more complex? Could dark matter nebulae be the precursors to unknown cosmic structures, forming a hidden framework for the next stage of universal evolution? There's another possibility, one that's even more mind-bending. If dark matter nebulae are forming and changing, then could they be connected to black holes in some way? Black holes are regions where normal matter collapses under extreme gravity, creating singularities that warp space-time. But what if there's a hidden connection between dark matter and black holes? Could dark matter nebulae be feeding black holes in ways we've never understood, providing unseen mass that affects their growth and behavior? And here's the most unsettling question. Could dark matter nebulae themselves collapse into something even stranger than a black hole? If dark matter doesn't behave like normal matter, then what happens when it reaches extreme densities? Could there be an unknown kind of collapse happening within dark matter nebulae, forming objects that are neither black holes nor stars, but something entirely new? Could these invisible regions be home to structures that defy all known physics? And if so, what would happen if we ever found one? The deeper we dive into the mysteries of dark matter nebulae, the clearer it becomes that we are missing something fundamental about the universe. These vast, invisible structures are influencing everything around them, yet we still don't know what they are made of, how they form, or what secrets they might be hiding. But as our technology improves and our understanding of the cosmos deepens, we may one day unlock the truth about dark matter nebulae. And when that day comes, we might realize that our entire picture of reality has been incomplete all along. If dark matter nebulae are truly dynamic, evolving entities, then our entire understanding of cosmic evolution might need to be rewritten. What if these mysterious structures are not just passive clouds floating through space, but rather fundamental components of a hidden cosmic cycle? Could they be birthplaces for new forms of matter, or remnants of something ancient, something from a time before the universe as we know it? If they are moving, shifting, and interacting with other dark matter structures, then what larger processes are they a part of? There's an idea in cosmology called the cosmic web, the vast, large-scale structure of the universe, where galaxies are strung along filaments of dark matter like beads on a necklace. But what if the cosmic web isn't just a static structure? What if dark matter nebulae are part of a more complex, evolving network, constantly shifting and shaping the universe in ways we've never detected? Could these nebulae act as invisible bridges between galaxies, forming temporary structures that influence the movement of cosmic matter before dissolving and reforming elsewhere? If dark matter nebulae can shift and change, then they might be responsible for some of the most perplexing cosmic phenomena we've observed. For example, astronomers have detected galaxies that seem to be moving in unexpected ways, as if being pulled or pushed by an unseen force. Some of these galaxies are accelerating toward nothing, an empty void in space where no visible mass exists. Could these be interactions with dark matter nebulae? Could these unseen structures be distorting spacetime in ways that mimic gravitational forces? And what if the effects of these nebulae aren't limited to the vast scales of galaxies and clusters? Could dark matter nebulae be affecting things much closer to home, perhaps even within our own solar system? We already know that dark matter is present everywhere, even within the Milky Way, but what if certain regions have higher concentrations than others? If a dark matter nebula were drifting through our galaxy, could it subtly affect the orbits of planets, the trajectories of asteroids, or even the behavior of the Sun itself? Some theories suggest that dark matter might not just be passive, it could have weak interactions with normal matter under extreme conditions. If that's true, then could a dense dark matter nebula passing through a region of space have unexplained effects on the stars and planets within it? Could these nebulae be responsible for mysterious changes in stellar brightness, or unexplained fluctuations in the energy output of certain stars? Could they even be connected to the formation of strange cosmic objects, like rogue planets or ultra-diffuse galaxies? There's another mystery that dark matter nebulae might help explain: fast radio bursts. These are extremely powerful, millisecond-long bursts of radio waves that come from deep space. Scientists still don't know exactly what causes them, but some theories suggest they might be related to neutron stars, magnetars, or even advanced alien civilizations. But what if they're linked to dark matter nebulae? If these massive structures are shifting and evolving, could they be creating conditions that trigger these bursts of energy? Could dark matter interactions produce effects we've never anticipated? And speaking of unknown interactions, what if dark matter nebulae aren't just affecting normal matter, but also the fabric of space-time itself? There's a possibility that dark matter is connected to the strange phenomenon known as dark energy, the mysterious force causing the universe's expansion to accelerate. What if dark matter nebulae are playing a hidden role in this process? Could they be regions where dark energy and dark matter interact in ways we don't yet understand? If dark matter is capable of forming structures on a cosmic scale, then what happens when these structures collapse, merge, or dissipate? Could they release energy in ways we've never observed, contributing to the strange expansion of the universe? And here's something even more mind-bending. What if dark matter nebulae are linked to the multiverse? Some theories suggest that dark matter could be a kind of shadow matter from another dimension, a substance that exists alongside our own universe but barely interacts with it. If that's the case, then could dark matter nebulae be regions where our universe is overlapping with another? Could these invisible structures be more than just clouds of particles? Could they be gateways to something beyond our reality? The idea of dark matter nebulae as cosmic bridges between dimensions might sound like science fiction, but so did black holes before we discovered them. If dark matter is more than just an unseen force, if it has structure, dynamics, and possibly even unknown interactions, then we are only scratching the surface of its true nature. And if dark matter nebulae are drifting through space, evolving and changing over time, then studying them might reveal not only the missing mass of the universe but also its deepest secrets. What if the answer to the biggest questions in physics has been hiding in these invisible nebulae all along? If dark matter nebulae are truly shaping the universe in ways we don't yet understand, then their role might be far greater than just filling in missing mass in our equations. What if these massive, unseen structures are actively influencing the evolution of galaxies, the formation of cosmic structures, and even the birth and death of stars? If we could somehow map their movements, would we uncover hidden patterns that explain some of the biggest cosmic mysteries? One of the strangest things about the universe is how galaxies are distributed. They aren't scattered randomly. They form vast filaments and clusters, separated by immense cosmic voids. The standard explanation is that dark matter forms a cosmic web, providing the scaffolding around which normal matter gathers. But what if dark matter nebulae are responsible for much of this structure? Could they be acting like unseen rivers, guiding the flow of gas and dust in ways we've never detected? This could explain why some galaxies appear to be missing dark matter altogether. A few galaxies have been found that seem to behave as if they contain no dark matter at all, despite our understanding that dark matter is essential for galaxy formation. Could these galaxies have been stripped of their dark matter by interactions with a larger dark matter nebula? Or could they be drifting through a region where dark matter is unusually sparse, revealing the presence of an unseen structure? If dark matter nebulae can shift and move over cosmic time, then they might be influencing galaxies in ways we haven't even begun to consider. Imagine a massive dark matter nebula passing through a young galaxy billions of years ago. The gravitational pull of this invisible structure could have distorted the galaxy's shape, altering its evolution in ways that left permanent imprints we see today. Could some of the most unusual galaxy formations, like ring galaxies or ultra-diffuse galaxies, be the result of ancient interactions with dark matter nebulae? And if these nebulae are playing a role in shaping galaxies, Could they also be affecting individual stars? Some stars have been observed moving at extreme speeds, so-called hypervelocity stars that seem to have been ejected from their galaxies. While many of these are believed to be the result of interactions with supermassive black holes, could dark matter nebulae also be responsible? If a dense region of dark matter were to pass through a stellar system, could its gravitational influence accelerate certain stars, flinging them into intergalactic space? If dark matter nebulae can influence stars, then what about planets? Could their presence explain anomalies in planetary orbits, or even in the behavior of rogue planets? Planets that drift through space without orbiting any star? If dark matter nebulae are real, then some of these planets might have formed in regions with strong dark matter interactions, influencing their initial trajectories before they were ejected into the void. And then there's the biggest question of all: what happens inside these nebulae? If they're not just featureless clouds, but actual structures with density variations, then could they contain regions where physics behaves differently? If dark matter is made of yet undiscovered particles, then interactions within a dense nebula might create conditions where exotic physics emerges. Could dark matter nebulae be places where unknown particles form and decay in ways we've never observed? Some scientists speculate that dark matter might interact with itself through a hidden set of forces. If true, then dense dark matter nebulae could be sites of unseen interactions, where unknown processes take place beyond our reach. Could these nebulae contain exotic structures, clumps, filaments, or even unknown forms of matter that behave in ways we can't yet comprehend? And if there are regions of high dark matter density, could they have effects beyond just gravity? Could they alter the passage of time in subtle ways, creating regions where time flows slightly differently than in the rest of the universe? If dark matter is linked to gravity in ways we don't yet fully understand, could dark matter nebulae be causing minor distortions in the very fabric of space-time? These questions lead us to even more speculative possibilities. If dark matter nebulae have a structure, if they form and evolve, then could they be part of an even larger system? Could they be linked to other fundamental cosmic structures we haven't discovered yet? Could they be part of a hidden framework that shapes reality on a scale beyond anything we've ever imagined? And most importantly, what happens if we find a way to truly see them? Could the first direct detection of a dark matter nebula unlock a new era in physics? What if we could finally observe the true shape of these structures, revealing an entire hidden universe that has been right in front of us all along? The search for dark matter nebulae isn't just about filling gaps in our understanding of mass in the universe. It's about uncovering the missing framework of reality itself. The answers might be out there, waiting for us to finally discover what has been shaping the cosmos from the shadows. If dark matter nebulae are real, and if they are actively shaping the universe, then the implications are almost beyond comprehension. Imagine a vast, invisible ocean of matter flowing through space, forming currents, eddies, and unseen storms that push and pull galaxies, alter the paths of stars, and maybe even distort the very fabric of reality itself. We've always thought of dark matter as something passive, something that just sits there, exerting gravity but doing little else. But what if that assumption is wrong? What if these nebulae are dynamic, evolving, and perhaps even capable of interactions that go beyond just gravity? If that's the case, then the true nature of the universe might be far stranger than we ever imagined. What if the reason we haven't been able to detect dark matter directly is that we've been looking in the wrong way? If dark matter nebulae are real, then they might not be uniform clouds of particles. They could have complex internal structures, with regions of varying density, movement, and maybe even different physical properties. Could some parts of a dark matter nebula be denser than others? Could they act like invisible mountains in space, bending light and matter in ways we haven't yet understood? There have already been hints that dark matter doesn't behave exactly as we expected. Observations of galaxy collisions, like the famous bullet cluster, have shown that dark matter doesn't always move in the way our models predict. Could this be because we're actually seeing the effects of dark matter nebulae? Could some of these nebulae be colliding with each other, creating vast, unseen shockwaves that ripple through the universe? If dark matter does interact with itself in some unknown way, then these nebulae could be sites of extreme cosmic activity, places where invisible forces are shaping reality in ways we can only guess at. And if these nebulae are real, then could they be part of something even larger? We've mapped out the structure of the visible universe, and we see vast cosmic filaments stretching across billions of light years. But what if those filaments are just the visible part of something even greater? Could dark matter nebulae be forming an unseen network, connecting galaxies in ways we can't yet detect? If dark matter is responsible for the large-scale structure of the universe, then perhaps these nebulae are the missing pieces of the puzzle, pieces that, once understood, could reveal the true shape of the cosmos. But there's an even deeper question lurking beneath all of this. If dark matter nebulae exist, then what created them? Are they just a natural consequence of dark matter physics, or do they point to something even more fundamental? Could they be relics from the very earliest moments of the universe, remnants of a time before normal matter even existed? Or could they be forming even now, growing and evolving in ways we've never imagined? If they are ancient relics, then studying them could tell us about the universe's earliest history, about what happened in those first moments after the Big Bang, before stars and galaxies had even formed. But if they are still forming today, then that means dark matter might be far more active than we ever thought. It would mean that the universe is still changing in ways we can't see, shaped by forces we don't yet understand. And here's where things get really strange. What if dark matter nebulae aren't just structures within our universe, but something deeper? What if they represent a kind of hidden boundary between different aspects of reality? If dark matter is connected to forces beyond the four fundamental forces we know, then could these nebulae be places where those unknown forces become more apparent? Could they be the missing link between our universe and something else, another dimension, another form of matter, or even another universe altogether? Some physicists have speculated that dark matter might not be entirely separate from normal matter, that under certain conditions, it might be able to interact in ways we haven't yet detected. If that's true, then dark matter nebulae might be the key to unlocking those interactions. Could they be places where dark matter temporarily becomes visible, where unknown forces leak into our reality, creating brief, unexplained cosmic events? Could they be responsible for some of the most mysterious astronomical phenomena we've observed, things like fast radio bursts, gamma-ray flashes, or unexplained gravitational anomalies? And if they do interact with normal matter, then could they even affect life? If dark matter nebulae exist within our own galaxy, then that means our solar system might have passed through one at some point in its history. Could such an encounter have influenced the development of life on Earth? Could fluctuations in dark matter density have subtly altered the conditions of our planet, shaping our evolution in ways we've never considered? If dark matter nebulae are real, then the entire universe might be far more dynamic and interconnected than we ever thought. These structures could be the hidden architects of reality, shaping the cosmos in ways we've never imagined. And if we can find a way to truly detect them, to study them directly, then we might finally uncover the missing piece of the puzzle, the key to understanding not just dark matter, but the deepest mysteries of existence itself. If dark matter nebulae exist and shape the universe in ways beyond our current understanding, then we are standing on the edge of a discovery that could redefine physics itself. These invisible structures, if they truly interact with galaxies, stars, and perhaps even entire cosmic events, could be the missing link between the universe we see and the hidden forces we have yet to uncover. But what if they are even more than that? What if dark matter nebulae are not just passive cosmic structures but active participants in the evolution of the universe? Consider the possibility that dark matter nebulae are not just clouds of unknown particles, but something far more complex. If they have variations in density, then they might not just influence gravity. They could shape the movement of entire galaxies in ways we haven't even begun to consider. If a dark matter nebula moves through a region of space, it could create gravitational waves strong enough to bend the paths of stars and alter the formation of new planetary systems. It could create regions of stronger or weaker gravitational influence, potentially explaining why some galaxies rotate at unexpected speeds or why certain star clusters appear more densely packed than others. And if these nebulae are massive, what happens when two of them collide? We've seen galaxy collisions, massive, slow-motion cosmic crashes that reshape entire galactic structures over millions of years. But what about dark matter nebulae? If they collide, would we even be able to detect it? Could such collisions create massive, invisible shockwaves, altering the movement of matter and energy in ways we don't yet understand? Could some of the unexplained cosmic phenomena we've observed, such as bursts of high-energy radiation or fluctuations in gravitational lensing, be the result of dark matter nebulae interacting with one another? If dark matter nebulae exist in large enough concentrations, they might even explain some of the most perplexing mysteries in astrophysics. One of the strangest phenomena we've observed in space is the existence of supermassive black holes at the centers of galaxies. These behemoths shouldn't have been able to form as quickly as they did in the early universe, and yet they are there. Could dark matter nebulae have played a role? If dark matter is capable of collapsing under certain conditions, could these nebulae have helped accelerate the formation of black holes? Could they have funneled matter into certain regions of space, providing the gravitational seeds needed for these cosmic monsters to emerge so rapidly? And then there's the question of time itself. If dark matter interacts with gravity in unknown ways, could dark matter nebulae be affecting the very nature of time? General relativity tells us that massive objects warp spacetime, and dark matter is estimated to be 5 times more abundant than normal matter. If dark matter nebulae are large enough, could they create regions where time moves at a slightly different rate? Could they be responsible for unexplained time distortions observed in astronomical data? If dark matter has an effect on time, then our understanding of the universe's history might need to be re-examined. What if some regions of space have been aging differently due to the presence of these hidden nebulae? But what if dark matter nebulae do more than just influence the cosmos? What if they are capable of directly interacting with normal matter under certain conditions? If dark matter isn't completely inert, if it has interactions beyond gravity, then these nebulae might be places where those interactions become more pronounced. Could dark matter nebulae be responsible for strange cosmic radiation bursts that have no known origin? Could they create temporary distortions in the fundamental forces of nature, leading to unexplained shifts in energy levels across the universe? And if they do interact with normal matter, then could they also be influencing life itself? We often think of life as something bound to planets, dependent on sunlight and stable conditions. But what if dark matter plays a hidden role in the evolution of life? If dark matter nebulae exist within galaxies, then it's possible that entire planetary systems have spent millions of years passing through these invisible clouds. Could these nebulae have influenced the chemical composition of planets, subtly altering the course of biological evolution? Even more strangely, what if life itself has evolved to interact with dark matter? If dark matter is truly abundant in the universe, then there is a possibility that unknown forms of life, completely different from anything we understand, could have emerged within these nebulae. Could there be entire ecosystems, made of unknown particles, existing in a form of matter we haven't yet detected? If dark matter can form structures, could it have created something analogous to biological systems, patterns of self-sustaining complexity that function in ways beyond our comprehension? If dark matter nebulae hold the answers to these questions, then the implications stretch far beyond physics and astronomy. They could redefine our understanding of reality itself. They could be the key to unlocking hidden forces in the universe, revealing not just the structure of the cosmos but the fundamental rules that govern existence. And if we ever develop the technology to interact with dark matter directly, what might we discover? Could we harness the energy of dark matter nebulae, tapping into an unseen source of power that has been influencing the universe for billions of years? Could they be used to develop new forms of transportation, allowing us to manipulate gravity itself? If dark matter nebulae contain unknown physics, could they even be the key to understanding the mysteries of space-time travel, perhaps opening doors to possibilities we once thought were confined to science fiction? The search for dark matter nebulae isn't just about explaining an invisible mass in the universe. It's about uncovering the hidden layers of reality, about revealing structures that could change everything we know about physics, time, and existence itself. If these nebulae are real, then they could be the bridge between what we know and what we have yet to discover. They could be the missing piece of the puzzle, the final key to understanding the forces that shape the universe from the shadows. If dark matter nebulae are more than just passive clouds, then the way we perceive the universe might be fundamentally flawed. Imagine a universe where these massive, invisible structures are constantly shifting, evolving, and perhaps even colliding, creating gravitational ripples that subtly alter everything we think we understand about space and time. If they are dense enough, they could be distorting entire regions of the cosmos without us even realizing it. This raises a deeply unsettling question: how much of our understanding of the universe is incomplete because we are missing this crucial, unseen force? Consider the possibility that dark matter nebulae are not just static structures, but dynamic entities that move, interact, and influence their surroundings. What if these nebulae are responsible for some of the strangest cosmic anomalies we've ever detected? For example, there are galaxies that seem to be rotating too fast, defying our current models of physics. While dark matter is already believed to be the culprit, what if these galaxies are actually passing through or trapped within enormous dark matter nebulae? If these nebulae are denser in some areas and more diffuse in others, they could create localized distortions in gravity, explaining why some galaxies behave in seemingly impossible ways. But the implications go even deeper. If dark matter nebulae are vast enough, could they act like gravitational wells, pulling in not just normal matter but even light? We know that black holes can bend and warp light through their immense gravitational pull, but could dark matter nebulae do something similar, though on a much larger scale? If so, they could be creating hidden, gravitational lenses that distort our view of distant galaxies. What if some of the galaxies we observe in deep space don't actually exist where we think they do? If dark matter nebulae are bending light in complex ways, then entire sections of the universe might appear stretched, duplicated, or even displaced from their actual positions. Now, let's take this even further. If dark matter nebulae are moving through space, then their gravitational effects wouldn't just be constant, they would be changing over time. Could this explain some of the strange, sudden shifts we've seen in deep space phenomena? Some stars appear to accelerate or decelerate in ways that defy explanation. Some cosmic signals, like fast radio bursts, arrive unpredictably, as if something is shifting the space they travel through. If dark matter nebulae are massive enough, they could be acting like invisible tides, subtly pushing and pulling on celestial objects as they drift across the cosmos. But here's where things get really strange. If dark matter nebulae are capable of warping the fabric of space, what does that mean for time itself? Einstein's theory of relativity tells us that gravity and time are intimately connected. Strong gravitational fields slow the passage of time. We already know that time moves more slowly near black holes, but could dark matter nebulae create a similar effect on a much larger scale? If so, then different parts of the universe could be experiencing time at slightly different rates, creating an unseen temporal distortion field that subtly alters cosmic history. Could some galaxies be aging more slowly than others without us realizing it? Could some regions of space be stuck in a kind of temporal lag, where light and energy behave differently because of the influence of an invisible force? And if time itself is being distorted by dark matter nebulae, then could this have affected the early evolution of the universe? The Big Bang is often described as a singular event, an explosion that expanded outward uniformly. But what if that's not entirely true? What if dark matter nebulae, existing even in the earliest moments of the universe, caused certain regions to expand at different rates? This could mean that some parts of the universe are older or younger than they should be, hidden by the fact that we can only observe the cosmos from our own limited perspective. If dark matter nebulae have been shaping cosmic expansion from the very beginning, then our entire model of the universe's history might need to be rewritten. And here's an even more mind-bending possibility. What if dark matter nebulae are connected to dark energy? Right now, dark matter and dark energy are considered separate phenomena. Dark matter pulls things together with gravity, while dark energy drives the expansion of the universe. But what if they are actually two sides of the same coin? If dark matter nebulae are vast enough, could they be exerting forces that counteract their own gravity under certain conditions? Could some nebulae be behaving like negative gravity zones, subtly accelerating the expansion of space rather than slowing it down? If so, then these nebulae might not just be influencing the shape of galaxies. They could be directly responsible for the very structure of the cosmos itself. And then there's the question of what happens when dark matter nebulae interact with normal matter. If they are truly invisible, then we shouldn't be able to detect them with ordinary telescopes. But what if some dark matter nebulae have small but crucial interactions with regular particles? If a dark matter nebula passes through a region of space dense with gas and dust, could it trigger unknown reactions that lead to the formation of new stars and planets? Could dark matter nebulae be acting as unseen seeds for star formation, helping shape the galaxies in ways we've never considered? This raises an even more intriguing question. What happens when a dark matter nebula passes through our own solar system? Could it have already happened in the past? If dark matter nebulae are drifting through the universe, then Earth itself might have encountered one at some point in its history. If a dark matter nebula has ever passed through our solar system, could it have affected planetary orbits, subtly shifting the way our solar system evolved? Could it have influenced the asteroid belt, altering the paths of space rocks and possibly even increasing the chances of impacts with Earth? And what if dark matter nebulae have interacted with Earth in ways we haven't yet recognized? If dark matter has subtle interactions with normal matter, could it have affected Earth's atmosphere, its magnetic field, or even biological evolution? Could certain unexplained climate shifts in Earth's history be linked to invisible cosmic forces moving through our region of space? If dark matter nebulae are real and as massive as they might be, then they could be one of the most important factors shaping the past, present, and future of the universe. They could be responsible for unexplained cosmic events, distortions in time and space, and even the fundamental structure of galaxies. If we could find a way to directly detect them, to map their locations and movements, then we might finally unlock some of the deepest secrets of the cosmos. But what if we already have clues? What if some of the unexplained astronomical data we've gathered, mysterious fluctuations in gravity, unexpected distortions in starlight, unexplained cosmic radiation bursts, are already pointing us toward the presence of dark matter nebulae? What if we've been seeing their effects all along but simply didn't recognize what we were looking at? If we can prove that dark matter nebulae exist, then it could lead to a revolution in physics, one that could challenge everything we thought we knew about the universe. It could reveal new forces, hidden structures, and even unknown forms of matter that have remained undetected for all of human history. And if we can find a way to interact with dark matter directly, then it might open up possibilities beyond our wildest imagination, new energy sources, new technologies, and perhaps even a new understanding of the nature of reality itself. The question is, how close are we to finding the truth? And when we finally do, will we be ready for what it reveals? If dark matter nebulae are truly out there, silently shaping the universe, then we are standing on the edge of one of the greatest discoveries in human history. But there's a problem. How do you study something that doesn't emit light, doesn't interact with electromagnetic forces, and is completely invisible to our most powerful telescopes? This is the fundamental paradox of dark matter. We know it's there because of its gravitational influence, but we have almost no direct way of detecting or studying it. And if dark matter nebulae exist as massive, drifting clouds, then the challenge becomes even greater. Imagine a dark matter nebula hundreds of light years wide, passing silently through the cosmos like a phantom. If it were made of normal gas and dust, we could see it easily. Infrared telescopes would pick up its heat, radio telescopes could detect the electromagnetic signals bouncing through it, and optical telescopes would reveal its faint glow. But a dark matter nebula? It would be completely invisible, detectable only by the way it warps the space around it. It wouldn't block light like a traditional nebula, nor would it emit any radiation. Instead, it would act like an unseen gravitational force, bending the paths of stars, altering the rotation of galaxies, and subtly shifting the cosmic web that connects everything in the universe. And this leads to an even bigger question. How many of these nebulae are there? Are they rare, existing only in isolated pockets of the cosmos? Or are they everywhere, filling the universe in a vast, unseen network of invisible clouds? If they are common, then we might be living inside one right now. Our entire galaxy could be drifting through a massive dark matter nebula without us even realizing it. And if that's true, then every calculation we've ever made about gravity, cosmic expansion, and galactic evolution might be missing a crucial, invisible factor. Some scientists have already proposed that dark matter is not evenly distributed throughout the universe but instead forms dense clumps or filaments. If this is correct, then dark matter nebulae could be a natural consequence of this cosmic structure. They could form in regions where dark matter is unusually concentrated, drifting through the universe like celestial ghosts. And if they interact with galaxies in unpredictable ways, they could explain some of the biggest cosmic mysteries we've ever encountered. For instance, there are galaxies that seem to contain almost no dark matter at all, places where stars and gas behave as if only normal matter is present. This is strange because dark matter is thought to be essential for holding galaxies together. But what if these galaxies once had dark matter, but it was stripped away by a passing nebula? If a massive dark matter cloud drifted through a galaxy, it could have gravitationally pulled its dark matter away, leaving behind only the visible matter. This would mean that dark matter nebulae aren't just passive clouds. They could be dynamic forces, capable of reshaping entire galaxies. And then there are galaxies that seem to contain far too much dark matter, places where gravity is stronger than it should be, where stars orbit at speeds that defy explanation. If dark matter nebulae exist, then some of these galaxies might simply be passing through one. A dark matter nebula could be adding extra gravitational pull to a galaxy, making it appear more massive than it really is. This would mean that some of the most puzzling galaxies we've ever observed might not be anomalies at all. They could just be surrounded by massive, unseen clouds of dark matter. But here's where things get really weird. If dark matter nebulae exist, then could they interact with themselves? We don't fully understand how dark matter behaves, but some theories suggest that it might be able to clump together under certain conditions. If this is true, then dark matter nebulae might not just be isolated clouds. They could be colliding, merging, and even forming structures of their own. This could mean that the universe contains entire regions where dark matter is more concentrated, forming invisible galaxies of pure dark matter that exist alongside the normal matter we can see. And if these dark matter structures exist, could they contain planets? Could entire star systems be forming inside dark matter nebulae, hidden from view? Right now, we assume that all stars and planets are made of normal matter, because that's all we've ever observed. But what if there are regions of space where dark matter is dense enough to form stable structures? Could there be dark matter planets, orbiting invisible, dark matter stars, completely undetectable by our instruments? If such worlds exist, they would be unlike anything we've ever imagined, places where physics might work differently, where time and gravity might behave in ways we don't yet understand. And if dark matter nebulae are common, could they be affecting space travel? Right now, our spacecraft navigate using gravity and electromagnetic signals. But if a dark matter nebula were drifting through the solar system, would we even know? If it were dense enough, could it subtly alter the paths of space probes, making their trajectories slightly different from what we expect? Could unexplained deviations in spacecraft motion be evidence that dark matter nebulae are passing through our cosmic neighborhood? This raises an even bigger question. Could dark matter nebulae affect Earth itself? If a massive dark matter cloud drifted through our solar system millions of years ago, could it have influenced our planet's history? Some scientists have speculated that dark matter could interact weakly with normal matter, meaning that if a dense dark matter nebula passed through the solar system in the past, it might have triggered subtle changes in planetary orbits, affected Earth's climate, or even influenced biological evolution in ways we don't yet understand. And what about the future? If dark matter nebulae are drifting through the cosmos, then it's possible that one could eventually pass through our solar system. If this were to happen, would we be able to detect it before it arrived? Would it have any noticeable effects on Earth? If dark matter can interact with normal matter in even the slightest way, then a passing nebula might subtly alter the balance of forces in our solar system, causing minor, but potentially significant, changes in the orbits of planets, moons, and asteroids. But what if dark matter nebulae are even more mysterious than we think? What if they are not just passive clouds, but something more, something that might be connected to the fundamental forces of the universe? Some physicists have speculated that dark matter could be linked to unknown forces, possibly even extra dimensions. If this is true, then dark matter nebulae might not just be invisible clouds of particles. They could be the key to unlocking an entirely new understanding of reality. What if dark matter nebulae are more than just drifting clouds? What if they are gateways, regions where the laws of physics behave differently? Could they be linked to wormholes, hidden dimensions, or even exotic forms of energy that we have yet to discover? If we could find a way to study them, could they lead us to breakthroughs in physics that go beyond anything we've ever imagined? Could dark matter nebulae be the missing piece of the puzzle that finally unites gravity, quantum mechanics, and the fundamental nature of space and time? And if that's the case, then what happens when we finally figure out how to interact with them? If dark matter nebulae hold the secrets to new forces, new dimensions, or even new forms of energy, then they could be the key to the future of space travel, energy production, and even the survival of our species. But before we can answer these questions, we first have to prove that dark matter nebulae exist, and that might be one of the greatest challenges in the history of science. The question is, are we ready to uncover the truth? And if we do, will it change everything we thought we knew about the universe? If dark matter nebulae exist, then the implications go far beyond just understanding the structure of the universe. They could redefine our entire approach to physics, cosmology, and even the nature of existence itself. The search for dark matter has already forced scientists to rethink long-standing theories about gravity, particle physics, and the fundamental forces that shape reality. But if dark matter nebulae are real, then we are dealing with something far stranger than we ever imagined: massive, invisible structures that exist alongside the ordinary universe, interacting with it in ways we barely understand. One of the biggest mysteries about dark matter nebulae is their potential interaction with other fundamental forces. Right now, dark matter is thought to interact only through gravity, meaning it doesn't emit, absorb, or reflect light. But what if that assumption is wrong? What if dark matter nebulae can interact with normal matter in subtle ways? Some physicists believe that dark matter might have its own forces, its own physics, and even its own unknown particles. If this is true, then dark matter nebulae could be more than just gravitational anomalies. They could be cosmic laboratories where the laws of physics behave differently. If dark matter nebulae interact with themselves, they might not be uniform clouds at all. Instead, they could have internal structures, density variations, and even dynamic behavior. Some models suggest that dark matter could form filaments and clumps within galaxies, meaning that dark matter nebulae might have complex, shifting structures that change over time. These nebulae might be growing, collapsing, or even colliding with each other, creating massive, invisible shockwaves that ripple across the universe. And if dark matter can interact with itself in ways we don't yet understand, then these nebulae might contain unknown forms of matter that don't exist anywhere else in the cosmos. Could dark matter nebulae be the key to solving some of the biggest mysteries in astrophysics? For example, astronomers have long been puzzled by fast radio bursts, intense, millisecond-long pulses of radio waves that seem to come from distant galaxies. These bursts appear out of nowhere and disappear just as quickly, with no clear explanation for what causes them. Some scientists have speculated that fast radio bursts might be linked to dark matter interactions, perhaps caused by dark matter particles annihilating each other, or by unknown forces within dark matter nebulae. If that's true, then dark matter nebulae might not be completely invisible after all. They might occasionally leave behind strange signals, clues that could help us detect them. And then there's the possibility that dark matter nebulae could be influencing entire galactic clusters. Right now, the largest structures in the universe, clusters of thousands of galaxies, are held together by an unseen gravitational force. We assume this is caused by vast amounts of dark matter, but what if some of these forces are actually caused by enormous dark matter nebulae drifting through intergalactic space? If dark matter nebulae can form on massive scales, then they might be acting like invisible gravitational glue, holding entire regions of the universe together. And if these nebulae are dynamic, moving and shifting over time, then they could be responsible for unexplained movements within galaxy clusters, motions that don't match our models of dark matter distribution. And what if dark matter nebulae are connected to black holes? Black holes and dark matter are two of the most mysterious objects in the universe, and some physicists have speculated that they might be linked. Could dark matter nebulae be feeding black holes, slowly funneling invisible mass into them? Or could dark matter nebulae be hiding inside black holes themselves, forming invisible structures within the event horizon? If dark matter interacts with itself, then it's possible that black holes could be surrounded by dense clouds of dark matter, nebulae that orbit just outside the event horizon, shaping the way black holes grow and evolve over time. If dark matter nebulae exist, then the way we think about space travel might need to change completely. Right now, all of our models of interstellar travel assume that space is mostly empty, aside from occasional gas clouds and asteroid fields. But what if dark matter nebulae are scattered throughout the universe, invisible obstacles that spacecraft could pass through without even knowing it? If dark matter has even the slightest interaction with normal matter, then traveling through a dense dark matter nebula could have unexpected consequences. Could dark matter nebulae subtly slow down spacecraft? Could they distort the passage of time? If a spaceship were to pass through a dense enough dark matter cloud, would it experience strange gravitational effects? Effects that could be mistaken for glitches in navigation systems? And here's an even stranger thought. Could dark matter nebulae be affecting time itself? Some theories suggest that dark matter could be linked to exotic physics, possibly even extra dimensions. If dark matter nebulae are dense enough, could they warp time in subtle ways? Could regions of space filled with dark matter experience time differently than the rest of the universe? If so, then some of the most mysterious anomalies in space, like unexplained time discrepancies in pulsar signals, or the strange behavior of certain distant galaxies, could actually be the result of dark matter nebulae subtly distorting time. But there's an even more unsettling possibility. What if dark matter nebulae are affecting us right now, without us realizing it? If dark matter interacts with itself, then it's possible that Earth has passed through dark matter nebulae in the past. And if these nebulae have even the faintest interaction with normal matter, then they might have left behind tiny, undetectable effects. Could changes in Earth's climate, unexplained shifts in planetary orbits, or even fluctuations in fundamental constants of physics be the result of encounters with invisible dark matter clouds? Could the entire history of our solar system have been influenced by something we can't even see? And if dark matter nebulae are real, then what else is hiding out there in the dark? Could there be entire galaxies made of nothing but dark matter, orbiting just beyond the reach of our telescopes? Could there be ancient, unknown structures hidden within dark matter clouds, structures that might hold the key to understanding the true nature of the universe? If dark matter nebulae exist, then we are living in a universe far stranger than we ever imagined. The search for dark matter nebulae is just beginning. But if we ever find them, the answers they hold could change everything. The universe we thought we knew might just be the tip of the iceberg, and beyond it lies a cosmic ocean filled with unseen forces, unknown physics, and mysteries waiting to be uncovered. The question is, are we ready for what we might find? If dark matter nebulae truly exist, then we might be standing on the edge of one of the greatest discoveries in the history of science. Imagine for a moment that the universe is not just what we see, but something far greater, something layered, with hidden structures and forces that have shaped cosmic evolution in ways we have yet to comprehend. If these nebulae are real, then every galaxy, every star, every black hole, and even the vast empty spaces between them may be part of a much larger, hidden network of dark matter clouds, each exerting a silent but profound influence on everything around them. But what if dark matter nebulae are not uniform? What if they come in different types, densities, and even behave in unexpected ways? Some theories suggest that dark matter itself might not be a single entity but a mixture of multiple unseen components, each with its own properties. If that's the case, then dark matter nebulae could be vastly different from one another. Some might be diffuse, barely interacting with normal matter, while others might be dense enough to cause gravitational distortions that subtly affect the movement of stars and planets. Could it be that dark matter nebulae are the reason why some galaxies appear to spin in ways that defy our expectations? Could they be responsible for the strange gravitational anomalies that astronomers have observed in deep space? One of the biggest questions about dark matter is whether it can form stable structures. If normal matter can form stars, planets, and entire galaxies, then why wouldn't dark matter do the same? Some scientists speculate that dark matter nebulae might be precursors to much larger, more complex structures, perhaps even dark matter galaxies that are completely invisible to us. If dark matter can clump together under the influence of its own gravity, then there may be entire regions of the cosmos filled with hidden formations, from vast dark matter clouds drifting through intergalactic space to massive, unseen halos surrounding normal galaxies. But here's where things get even more fascinating. What if dark matter nebulae are not just passive clouds of invisible mass but dynamic, evolving entities? If dark matter has self-interactions that we don't yet understand, then these nebulae might not just sit there. They could move, shift, and even collapse under their own gravity. Imagine entire regions of space where invisible tides flow, where dark matter streams merge and break apart, forming structures that no telescope can see. If dark matter nebulae behave anything like their ordinary matter counterparts, they might even have cycles of growth and decay, perhaps slowly dispersing over billions of years or suddenly condensing into dense regions that affect the behavior of nearby galaxies. And what about their interaction with black holes? If dark matter nebulae exist, then they could be feeding some of the largest black holes in the universe, supplying them with a constant stream of unseen mass. Right now, astrophysicists are puzzled by the existence of supermassive black holes that appear to have formed too quickly after the Big Bang. Could it be that dark matter nebulae played a role in their formation? If these invisible clouds were dense enough in the early universe, they might have accelerated the growth of black holes, allowing them to reach enormous sizes much faster than our current models predict. There's also the question of whether dark matter nebulae could be indirectly detected. If they are massive enough, they should create gravitational lensing effects, bending the light from distant galaxies and distorting our view of the cosmos. Some astronomers believe that certain unexplained lensing events might be caused by dark matter clouds, acting like giant cosmic magnifying glasses that warp the fabric of spacetime itself. If that's true, then with the right observations, we might be able to map these nebulae, revealing the hidden dark matter structures that lurk in the depths of space. But perhaps the most intriguing possibility is that dark matter nebulae might not be entirely made of dark matter. What if, within these massive invisible clouds, there are small amounts of exotic particles, things that don't fit into our standard model of physics? Some scientists have proposed the existence of dark photons, hypothetical particles that could interact with both dark matter and normal matter under very specific conditions. If dark matter nebulae contain dark photons or other unknown forces, then they might not be completely undetectable. Instead, they might leave behind subtle, strange signals, anomalies in cosmic background radiation, unexplained shifts in particle behavior, or even bizarre energy fluctuations that hint at an unseen presence. And then there's the question of whether dark matter nebulae could have played a role in shaping the Milky Way itself. Right now, our galaxy is surrounded by a vast halo of dark matter, an invisible structure that extends far beyond the stars we can see. But what if, billions of years ago, the Milky Way formed within a dense dark matter nebula? What if our galaxy's rotation, its spiral arms, and even the distribution of stars were influenced by the invisible mass that once surrounded it? If dark matter nebulae helped sculpt galaxies, then they might be responsible for the very structure of the universe as we know it. And here's an even stranger thought. What if dark matter nebulae are affecting our solar system right now? Scientists have long been puzzled by the unexplained orbits of certain distant objects in the outer solar system, Kuiper belt objects, and dwarf planets that seem to move in ways that don't fully align with our models of gravity. Some have suggested that an unseen mass, possibly a hidden planet, could be responsible. But what if the answer is even more bizarre? What if a dark matter nebula, drifting through interstellar space, occasionally passes through our solar system, subtly tugging on planetary orbits and leaving behind anomalies that we struggle to explain? And what if dark matter nebulae are not just cosmic relics, but active players in the ongoing evolution of the universe? Could they be influencing the formation of new stars, helping to trigger supernova explosions, or even playing a role in mysterious astrophysical events like gamma ray bursts? If dark matter nebulae can interact with normal matter in ways we don't yet understand, then they might be affecting the life cycle of entire galaxies, shaping cosmic history in ways that have gone unnoticed until now. But the biggest question of all is this: what happens if we find one? What if, after decades of searching, scientists detect a dark matter nebula, an enormous, invisible cloud with undeniable gravitational effects? If that day comes, it will be one of the greatest breakthroughs in physics, forcing us to rethink everything we know about the universe. But it will also raise even deeper questions. What else is hidden in the dark? How many of these nebulae are out there? And what strange new forces might we uncover if we keep looking? The search for dark matter nebulae is only just beginning. But one thing is certain: if they are real, then the universe is far stranger than we ever imagined. And the mysteries waiting to be uncovered might be even bigger than we can possibly comprehend. If dark matter nebulae exist, then the implications stretch far beyond just astrophysics. They challenge our entire understanding of reality. For decades, we've assumed that the universe operates according to laws we can observe and measure, but dark matter remains one of the biggest exceptions. It refuses to emit, absorb, or reflect light, making it completely invisible to our telescopes. And yet, we know it must be there, shaping galaxies, bending space, and exerting its influence on everything from the cosmic web to the tiniest fluctuations in the early universe. But what if our assumptions about dark matter are wrong? What if dark matter nebulae are not just hidden clouds of mass but something far more exotic? Some physicists believe that dark matter could be an entirely different kind of substance, something that doesn't fit into our current understanding of particle physics. Instead of behaving like ordinary matter, dark matter could be part of an unknown, invisible force that interacts in ways we haven't yet detected. If dark matter nebulae exist, they might not just be passive clouds of mass, but dynamic structures that shift and evolve under forces we don't yet understand. Could it be that dark matter nebulae are interacting with themselves through a new kind of physics, something that goes beyond gravity? One of the strangest ideas in modern physics is that dark matter might be part of a hidden sector, a mirror universe of particles that interact with each other but remain mostly invisible to us. If that's the case, then dark matter nebulae could be the visible, or rather, gravitationally detectable, remnants of an entire hidden cosmos, a shadow universe that exists alongside our own. Imagine for a moment that these nebulae are not just clumps of mass, but entire regions where unseen forces are at play, regions where exotic physics creates phenomena we've never even conceived of. But how would we prove any of this? Right now, the best evidence for dark matter comes from its gravitational effects. But if dark matter nebulae exist, then we might be able to detect them through other means. Some theories suggest that dark matter could decay into detectable particles over long timescales, emitting faint but measurable signals. If dark matter nebulae contain exotic particles, they might occasionally release bursts of unknown radiation, tiny fluctuations that could be picked up by sensitive detectors. Could it be that we've already detected hints of dark matter nebulae without realizing it? One of the most compelling mysteries in astrophysics is the unexplained excess of high-energy positrons detected by space telescopes. Some researchers have suggested that these positrons could be the result of dark matter interactions, perhaps even decaying dark matter particles within massive unseen nebulae. If that's the case, then these nebulae might not be entirely invisible after all. Instead, they might leave behind subtle traces, tiny anomalies in cosmic radiation, unexplained energy signatures, or gravitational disturbances that don't quite fit our models. And what if dark matter nebulae are not just floating through space but actively influencing the formation of galaxies? Right now, one of the biggest unsolved questions in astrophysics is why galaxies form the way they do. We know that dark matter plays a role, acting as a kind of cosmic glue that holds galaxies together. But what if dark matter nebulae are the missing piece of the puzzle? If these massive clouds of invisible matter exist, they might be acting as cosmic scaffolding, shaping the very structure of galaxies before they even form. Consider this. When astronomers simulate galaxy formation, they find that ordinary matter alone isn't enough to create the spiral structures we see in the universe. Instead, something unseen seems to be guiding the process. pulling matter into place in ways that our equations struggle to explain. Could it be that dark matter nebulae act as cosmic blueprints, creating invisible gravitational landscapes that determine where galaxies can and cannot form? But what if dark matter nebulae are not just passive bystanders in this process? What if they actively change over time, shifting and evolving in ways that affect entire galactic structures? Some scientists believe that dark matter might have a kind of self-interaction, a weak force that allows it to clump together under the right conditions. If that's true, then dark matter nebulae might not be static. They might be in motion, drifting through space like unseen tides, creating waves of gravitational influence that subtly nudge galaxies, stars, and even entire clusters. If dark matter nebulae move, then they might be responsible for some of the strangest anomalies we see in the universe. Consider the unexplained movements of certain galaxy clusters, massive structures that seem to be accelerating or shifting in ways that don't quite make sense. Could it be that these clusters are moving through vast, invisible currents of dark matter, their paths altered by unseen forces? And what about the so-called cosmic voids? The enormous empty spaces between galaxy clusters? These voids are some of the most mysterious structures in the universe, vast, seemingly empty regions where few galaxies exist. But what if they're not empty at all? What if these voids are actually filled with dark matter nebulae, massive clouds of invisible substance that suppress galaxy formation, creating the illusion of emptiness? If that's the case, then dark matter nebulae might be shaping the very structure of the universe, acting as unseen barriers that determine where galaxies can and cannot form. And then there's the question of whether dark matter nebulae might exist within our own galaxy. Right now, we assume that dark matter is smoothly distributed in a vast halo around the Milky Way. But what if that's not entirely true? Some models suggest that dark matter might clump together in small, dense regions, perhaps even forming pockets of high-density dark matter right here in our cosmic backyard. If that's the case, then there could be dark matter nebulae drifting through interstellar space, completely undetectable except for their gravitational effects. But here's where things get even stranger. What if dark matter nebulae are not just passive structures, but active participants in the evolution of the universe? Could they be influencing the formation of new stars, triggering cosmic events, or even playing a role in some of the most mysterious phenomena in astrophysics? Some researchers have speculated that dark matter might play a role in unexplained cosmic explosions, events like fast radio bursts, sudden bursts of high-energy radiation that appear and disappear without warning. If dark matter nebulae contain exotic particles, then they might occasionally interact with normal matter in ways that produce brief but powerful energy releases. And then there's the ultimate question: what if dark matter nebulae contain unknown forms of matter, something beyond both normal and dark matter? Some theories suggest that there could be a third category of matter, something that exists in between the two, interacting weakly with both but remaining largely undetectable. If dark matter nebulae contain this unknown substance, then they might be the key to unlocking entirely new branches of physics, revealing forces and particles that have remained hidden from us since the beginning of time. If we could map these nebulae, if we could detect their presence beyond just gravitational effects, then we might be on the brink of one of the greatest discoveries in scientific history. It would change not just our understanding of the cosmos, but our place within it. Are we living in a universe shaped by forces we cannot see? Are there entire structures, hidden in the dark, that have been guiding cosmic evolution from the very beginning? The search for dark matter nebulae is not just a scientific pursuit, it is a quest to uncover the fundamental nature of reality itself. And if we do find them, what comes next? Will we be able to manipulate dark matter, to harness its power, to unlock new technologies that could change the course of human civilization? Or will dark matter nebulae remain forever beyond our reach, an invisible force that shapes the universe from the shadows, always present but never fully understood? The mysteries of dark matter nebulae are just beginning to unfold. And the deeper we look, the stranger the universe becomes. The idea that dark matter nebulae could be shaping the universe in ways we haven't even imagined is both exhilarating and unsettling. If these invisible structures exist, they could be the missing link in our understanding of the cosmos, holding together galaxies, influencing cosmic events, and even interacting with the very fabric of spacetime itself. But there's another possibility, one that is even more mind-bending. What if dark matter nebulae are not just passive accumulations of unseen mass, but something entirely different? What if they possess properties that defy our current understanding of physics? Consider this. We assume that dark matter only interacts gravitationally, but what if it has other, hidden interactions? Some theories propose that dark matter could be part of a hidden force, something beyond the four fundamental forces we currently know: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. If this is true, then dark matter nebulae might not just be invisible clouds of mass. They could be dynamic, evolving structures governed by forces that exist outside our observable universe. One of the most intriguing possibilities is that dark matter nebulae might be capable of forming structures on their own. We often imagine dark matter as a featureless, diffuse substance, but what if, under the right conditions, it can collapse into filaments, clumps, or even more complex formations? In other words, what if dark matter nebulae are not just massive, amorphous clouds, but rather highly structured regions of space? If this were the case, then these nebulae could be forming their own intricate networks, similar to the cosmic web of galaxies we see in the visible universe. The implications of this are staggering. If dark matter can form complex structures, then it might be possible that dark matter nebulae contain regions of higher density, areas where dark matter interacts with itself in ways we haven't yet observed. Some researchers speculate that dark matter might even be capable of forming dark stars, hypothetical objects that do not emit light but generate energy through dark matter interactions. If these dark stars exist within dark matter nebulae, then we might be looking at entire hidden regions of space, filled with unknown forms of matter, structured in ways we can barely comprehend. And then there's an even wilder possibility. What if dark matter nebulae are more than just structures? What if they are environments, places where unknown forms of physics operate? Imagine an entire region of the cosmos where the laws of physics, as we know them, do not apply in the same way. Could these nebulae be harboring strange, exotic phenomena, things we have never encountered in our visible universe? Some physicists have speculated that dark matter might have its own interactions, possibly even its own form of chemistry. If that's true, then dark matter nebulae could be sites where dark matter, atoms, or molecules, come together in ways that are completely alien to us. In other words, these nebulae could be the birthplace of an entirely different kind of structure, perhaps even something resembling life, but made entirely of dark matter. While this might sound like pure speculation, the fact remains that we simply do not know what dark matter is. If it has complex interactions, then the idea that dark matter nebulae could host exotic forms of self-organization is not entirely out of the question. But let's take this idea even further. If dark matter nebulae are not just clouds of unseen mass, but rather structured environments governed by unknown physics, then what does that mean for the nature of the universe itself? Could these nebulae be remnants of an earlier phase of the cosmos, a time when dark matter played a more active role in shaping reality? Some theories suggest that dark matter could be a leftover relic from a previous state of the universe, something that existed before normal matter took over. If that's the case, then dark matter nebulae might be like fossils, traces of a hidden history that predates everything we know. This brings us to one of the biggest questions in physics. What if dark matter nebulae are connected to something even bigger? Some researchers believe that dark matter might not just be a substance within our universe but rather a bridge to something beyond it. In this view, dark matter nebulae could be weak points in our universe's structure, places where hidden dimensions or parallel realities might be accessible. Could it be that dark matter nebulae are the key to unlocking the secrets of the multiverse? One of the most tantalizing ideas in theoretical physics is that dark matter could be interacting with forces that exist outside our observable universe. If that's the case, then dark matter nebulae might be acting as cosmic portals, regions where the boundaries between different parts of reality become thin. Some physicists have proposed that dark matter might be leaking in from another dimension, slowly accumulating in our universe in ways we don't yet understand. If that's true, then dark matter nebulae could be more than just unseen clouds. They could be active conduits between different realms of existence. And then, of course, there is the biggest question of all. Could dark matter nebulae be hiding the answer to the origin of everything? If dark matter played a role in the formation of the first galaxies, the first structures in the universe, and possibly even the first moments of cosmic history, then understanding these nebulae might bring us closer to answering the deepest question of all. Why is there something rather than nothing? As we continue to search for these hidden structures, we may find that the universe is even stranger than we ever imagined. If dark matter nebulae exist, they could be influencing everything we see, shaping reality in ways that are currently invisible to us. They might be the missing key to understanding galaxy formation, cosmic voids, high-energy cosmic events, and even the fundamental nature of the universe itself. But the biggest mystery remains: if dark matter nebulae are out there, how can we find them? Right now, astronomers are searching for ways to detect dark matter beyond its gravitational effects. Some believe that high-energy cosmic rays might hold clues, while others think that dark matter might occasionally interact with normal matter in rare but detectable ways. If dark matter nebulae are releasing faint radiation, then we might already have the data. We just need to know where to look. And what happens if we do find them? The discovery of dark matter nebulae would be one of the most important breakthroughs in scientific history. It would force us to rewrite the laws of physics, to reconsider the nature of reality, and to question everything we thought we knew about the universe. It would be a discovery on the level of Newton's laws of motion, Einstein's theory of relativity, or the revelation that the universe is expanding. But perhaps the strangest thought of all is this: what if dark matter nebulae are not just out there in deep space, but closer than we think? What if they exist within our own galaxy, lurking in the void between stars, drifting through the Milky Way unseen? If that's the case, then the greatest mystery in the universe might not be light years away. It might be right here, hiding in the darkness all around us, waiting to be understood. And as we continue our search, as we build more powerful telescopes, launch more sensitive detectors, and push the boundaries of human knowledge, we may finally come face to face with the greatest mystery of all, the unseen universe that has been shaping our reality since the beginning of time. If dark matter nebulae truly exist within our own galaxy, drifting unnoticed through the cosmic void, then we must ask an even more unnerving question: have we already encountered their effects without realizing it? Could some of the strange, unexplained cosmic phenomena that have puzzled scientists for decades actually be the result of dark matter nebulae interacting with the visible universe? For example, astrophysicists have long struggled to explain certain anomalies in the rotation curves of galaxies. The outer edges of spiral galaxies rotate much faster than they should based on the visible mass alone. This is one of the strongest pieces of evidence for dark matter. But what if these inconsistencies are not caused by a smooth, even distribution of dark matter, but instead by dense, hidden nebulae of dark matter clustered in unexpected places? If these nebulae are not evenly spread throughout space but instead exist as concentrated regions of dark mass, then they could be exerting localized gravitational influences on stars, gas clouds, and even entire galactic arms. This could also explain some of the strange movements of certain star clusters. Astronomers have observed clusters of stars behaving as though they are being pulled by something unseen, something massive, yet completely invisible. While many assume this is due to the general presence of dark matter, what if it's actually caused by distinct, concentrated dark matter nebulae, exerting their gravitational pull in specific, highly localized ways? But gravity might not be the only force at play. If dark matter has additional interactions that we do not yet understand, then these nebulae could be doing more than just bending space-time. Some scientists have proposed that dark matter might interact weakly with itself, creating subtle but detectable effects. If true, then dark matter nebulae might not just be passive clumps of mass. They could be dynamic, evolving structures, capable of shifting, merging, or even fragmenting over time. This opens up another possibility. What if dark matter nebulae occasionally become dense enough to collapse? We know that in the visible universe, when enough mass gathers in one place, it can trigger the formation of stars, black holes, or even entire galaxies. If dark matter nebulae reach a certain critical mass, could they undergo a similar process? Could there be hidden, dark collapses, happening throughout the universe, leading to the creation of dark matter structures that we cannot yet perceive? If this is the case, then it's possible that dark matter nebulae are not just passive clouds, but active participants in cosmic evolution. They could be forming their own dark matter galaxies, their own dark matter structures, perhaps even their own dark matter stars. Some physicists believe that if dark matter can interact with itself in certain ways, then it could theoretically form exotic objects like dark stars, which would not emit light but would generate energy through unknown processes. These hypothetical objects could be lurking inside dark matter nebulae, hidden within the shadows of the cosmos. But what if dark matter nebulae are not just shaping the universe, they are also disrupting it? Some high-energy cosmic phenomena have defied explanation for years. Mysterious fast radio bursts, FRBs, strange cosmic rays, and unexplained gravitational lensing effects have all left scientists scratching their heads. Could these be signs of dark matter nebulae interacting with normal matter in rare, unexpected ways? One particularly strange phenomenon is the existence of cosmic voids, vast, empty regions of space where very few galaxies exist. While some voids can be explained by normal cosmological processes, others seem eerily too large, too empty, as if something is actively preventing matter from accumulating there. If dark matter nebulae exist, could they be acting as invisible barriers, pushing normal matter away, shaping the structure of the universe in ways we have yet to grasp? And here's where things get even stranger. What if dark matter nebulae are not just affecting the large-scale structure of the universe, but also playing a role in the fundamental physics of reality itself? Some physicists have proposed that dark matter might be linked to extra dimensions, hidden layers of reality that extend beyond the three spatial dimensions we experience. If this is true, then dark matter nebulae could be regions where these extra dimensions subtly influence our universe, bending space and time in ways we do not yet understand. This leads to an even wilder question. Could dark matter nebulae be the key to unlocking entirely new forms of physics? If dark matter interacts with itself in ways we have not yet discovered, then it might obey entirely different laws. Laws that could rewrite everything we know about the nature of the cosmos. Could these nebulae contain new particles, new forces, or even new states of matter that exist outside the boundaries of our current scientific understanding? And if dark matter nebulae are influencing reality on such a fundamental level, then what does that mean for the search for extraterrestrial life? If dark matter plays a more active role in the universe than we realize, then it's possible that alien civilizations, if they exist, might have discovered ways to harness it. Could advanced extraterrestrial beings have found a way to manipulate dark matter nebulae, using them as energy sources, travel pathways, or even hidden refuges? If so, then the discovery of dark matter nebulae might not just change our understanding of physics, it might also redefine our place in the cosmos. It could mean that we are not alone, that intelligent life elsewhere in the universe has already unlocked secrets that we have yet to even glimpse. But perhaps the most mind-blowing possibility is this: what if dark matter nebulae are not just shaping the cosmos, but are part of something even bigger? Some theories suggest that dark matter could be connected to a parallel universe, a hidden reality that exists alongside our own. If dark matter nebulae are regions where these two realities overlap, then they could be more than just clouds of unseen mass. They could be windows into another world, places where the boundaries between dimensions blur. If this is true, then the search for dark matter nebulae is not just about understanding the structure of the universe. It is about unlocking the greatest cosmic mystery of all. It could mean that the universe we see is only part of a much larger reality, one that extends beyond our perception, beyond our understanding, and perhaps even beyond our ability to comprehend. And as we continue our search, as we push the limits of science and technology, we may one day come face to face with the unimaginable. The discovery of dark matter nebulae could be the key to understanding not just the universe, but the very nature of existence itself. But until then, the mystery remains. Dark matter nebulae, if they exist, are out there, hidden, unseen, waiting to be discovered. And perhaps, in the not-so-distant future, we will finally unlock the secrets of the invisible universe, revealing a reality far stranger, far deeper, and far more complex than we ever dared to imagine. If dark matter nebulae are truly the missing key to understanding the cosmos, then the implications stretch far beyond astrophysics. These vast, invisible structures could be influencing everything, from the way galaxies form to the fate of the universe itself. But before we can even begin to understand their full impact, we must first ask a deeper question: how do these nebulae come into existence? Are they primordial, formed in the earliest moments of the universe? Or are they continuously evolving, growing, and changing over cosmic time? One possibility is that dark matter nebulae are remnants from the Big Bang, structures that condensed out of the high-energy chaos that followed the universe's birth. If this is true, then these nebulae could be ancient relics, older than the oldest galaxies, older than the stars themselves. But unlike the visible matter in the universe, which clump together to form galaxies, planets, and everything we see, dark matter doesn't interact with light, it doesn't emit, absorb, or reflect radiation. This means that while normal matter was busy forming into cosmic structures, dark matter might have followed a different path, forming massive clouds that drifted through the universe unnoticed. But what if dark matter nebulae are not just passive remnants, but active, evolving structures? If dark matter has even the slightest ability to interact with itself, then these nebulae could be dynamic. They could be slowly growing, merging, or even collapsing under their own gravity. In the visible universe, we see gas clouds collapsing to form stars, black holes feeding on matter, and galaxies colliding. Could dark matter nebulae be undergoing similar but unseen processes? Could they be forming their own versions of cosmic structures, dark matter galaxies, dark stars, or even dark planets? If such objects exist, then they would be completely invisible to our current telescopes, detectable only through their gravitational effects. This raises an unsettling question: what if some of the unexplained gravitational anomalies we observe in the cosmos are actually caused by hidden dark matter nebulae? Scientists have long been puzzled by certain unexplained forces acting on distant galaxies and star clusters. What if these are being pulled by massive, unseen nebulae of dark matter, exerting their influence in ways we have yet to comprehend? This also leads to another mind-bending idea. Could dark matter nebulae be affecting the very fabric of space-time itself? We know that dark matter influences gravity, but some physicists believe it might do more than just add mass to the universe. There are theories suggesting that dark matter could be connected to exotic physics, such as extra dimensions, hidden forces, or even a deeper layer of reality that we have not yet uncovered. If dark matter nebulae are dense enough, could they be warping space-time in ways we do not yet understand? Could they be creating subtle distortions in the structure of the cosmos, bending the universe in ways that challenge our current understanding of physics? And if dark matter nebulae can warp space and time, then what does that mean for the possibility of hidden structures within them? Some physicists have speculated that dense regions of dark matter might contain exotic objects, perhaps even entire dark matter civilizations. If dark matter can form structures, then is it possible that somewhere in the cosmos, intelligent life has evolved in an entirely dark matter-based environment? Could there be beings, living in the depths of these nebulae, completely invisible to us, existing in a parallel cosmic ecosystem that we cannot yet perceive? While this idea sounds like pure science fiction, it is not as far-fetched as it seems. If dark matter makes up the majority of the universe's mass, then why should life only exist in the tiny fraction of the universe that is made of normal matter? What if dark matter nebulae are not just empty voids, but the foundations of an entirely different kind of cosmic reality, one where physics operates differently, where life follows unknown rules, where civilizations may exist beyond the reach of our most advanced instruments? But perhaps the most chilling possibility is this: what if dark matter nebulae are not just shaping the universe, but also holding secrets about its ultimate fate? Scientists have long debated how the universe will end. Will it expand forever, slowly fading into darkness? Will it collapse in on itself in a reverse Big Bang? Or will some unknown force intervene, altering the course of cosmic history? If dark matter nebulae contain hidden forces, exotic physics, or even unknown forms of energy, then they could play a crucial role in determining the universe's ultimate destiny. Could these nebulae be reservoirs of a hidden energy that will one day accelerate the universe's expansion beyond control? Could they contain forces that will eventually trigger a cosmic phase transition, reshaping reality itself? And if dark matter nebulae are somehow linked to extra dimensions or parallel universes, could they be the gateways to something even larger than our own universe? A hidden multiverse, a cosmic structure so vast that our entire reality is just a small part of a much greater whole? As we continue our search, as we build better telescopes, as we push the limits of science and human understanding, we may one day uncover the truth about dark matter nebulae. And when we do, we may not just be answering questions about mass, gravity, and physics. We may be uncovering the greatest mystery of all, the very nature of existence itself. If dark matter nebulae are shaping the fate of the universe in ways we can't yet comprehend, then what does that mean for our understanding of reality itself? Could these vast, invisible clouds be more than just cosmic leftovers? Could they be the hidden scaffolding upon which the universe is built, the unseen foundation that determines the structure of everything we see? If so, then studying these nebulae isn't just about understanding the cosmos. It's about understanding the deepest rules of existence, the hidden laws that govern not just matter, but the very fabric of space and time. One of the most unsettling possibilities is that dark matter nebulae could be influencing reality at a quantum level. We often think of quantum mechanics as something that only applies to tiny particles, electrons, photons, and atoms. But what if dark matter operates on an entirely different quantum scale, one that affects space itself? Some physicists speculate that dark matter might not just be made of unknown particles, but of something even stranger: fluctuations in spacetime, distortions in the quantum field, or even remnants of a previous universe that existed before our own. If that's the case, then dark matter nebulae might not be simple structures at all. They might be places where the universe itself is different, where the laws of physics as we know them break down, where time, space, and gravity function in ways we can't even begin to predict. Imagine what that would mean. What if some regions of space, filled with dense dark matter nebulae, are actually places where time flows differently? What if these nebulae are warping the very nature of reality, creating cosmic pockets where time speeds up, slows down, or even loops in ways that defy our understanding? Some theories even suggest that dark matter could be linked to time itself, that it might hold the key to why time flows in one direction, why the past feels different from the future. If that's true, then dark matter nebulae might not just be cosmic clouds. They might be hidden engines of time itself, places where the very concept of past, present, and future starts to unravel. And if dark matter nebulae can influence time, then could they also be the key to understanding the origin of the universe? Some scientists believe that dark matter might have existed before the Big Bang, that it could be a relic from an earlier state of the cosmos. If that's the case, then dark matter nebulae might not just be random structures floating in space. They might be echoes of an older reality, remnants of a time before time, fragments of a universe that came before our own. Could these nebulae be the last surviving pieces of a previous cosmic cycle, a hidden record of universes that rose and fell long before ours even existed? This idea leads to another, even more unsettling possibility. If dark matter nebulae are relics of past universes, then could they also be shaping the future of the next one? Some theories suggest that our universe might not be the first, and it might not be the last. If dark matter nebulae are acting as cosmic memory banks, storing information from one universe to the next, then they could be playing a role in the birth of future realities. Could these nebulae be the seeds of the next Big Bang, the hidden structures that will one day collapse and give birth to a new universe? If so, then studying them might not just tell us where we came from. It might give us clues about what comes next, about how the cosmos will evolve beyond the limits of our own existence. But there's another, even stranger possibility, one that challenges everything we think we know about the nature of reality. What if dark matter nebulae are not just cosmic structures, but something more? What if they are evidence of an entirely separate form of existence, one that operates alongside our own, hidden in plain sight? Some physicists believe that dark matter could be linked to extra dimensions, to hidden layers of reality that we cannot yet detect. If that's true, then dark matter nebulae might not just be floating through space. They might be connected to something larger, something deeper, something that exists beyond the 3 dimensions we can perceive. Imagine if these nebulae are actually touching other worlds, other realms, other versions of reality. What if they are places where our universe brushes against something else, an alternate dimension, a parallel universe, or even an entirely different form of existence that operates according to its own rules? If that's the case, then dark matter nebulae could be cosmic doorways, hidden passageways between our world and something unknown. Could they be portals? Could they be the places where universes collide, where matter and energy leak from one reality into another? And if dark matter nebulae are connected to other dimensions, then what else might they be hiding? Could there be forces, entities, or even civilizations existing within them, beings that we cannot see, touch, or detect, but that are just as real as anything in our own world? If dark matter structures are truly separate from normal matter, then life that evolves within them would be completely invisible to us. It would exist in a form we cannot perceive, in a way we cannot yet understand. Could these nebulae be home to something else, something intelligent, something ancient, something that has been watching us from the darkness for longer than we can imagine? This idea is more than just speculation. Scientists have long been puzzled by unexplained gravitational anomalies, strange forces acting on galaxies and star systems that cannot be accounted for by known physics. What if these anomalies are caused by something inside dark matter nebulae? What if these nebulae are not just drifting through space, but actively shaping the cosmos in ways we have yet to realize? And if they are, then could they be communicating with each other, exchanging information across vast distances in ways we cannot yet detect? If dark matter nebulae are influencing gravity, time, and space itself, then they might be part of a hidden network, an invisible web that stretches across the entire universe. Could they be the backbone of an unknown cosmic intelligence, a system of structures that is shaping the universe's evolution without us even knowing? Could the universe itself be a living thing, guided by forces hidden within these nebulae, operating on scales so vast that we have only begun to scratch the surface of their true nature? As we continue to search for answers, as we build better telescopes, as we push the boundaries of what we know, one thing is clear: dark matter nebulae are not just cosmic mysteries. They are the key to something deeper, something stranger, something that may redefine everything we thought we understood about space, time, and reality itself. And when we finally uncover the truth, it may not just change our understanding of the universe. It may change the very nature of our existence. If dark matter nebulae are indeed shaping reality in ways we cannot yet comprehend, then we have to consider what that means for our place in the universe. Are we merely spectators, observing a cosmos that is governed by hidden forces we barely understand? Or are we an integral part of a much larger system, one that extends beyond visible matter, beyond the laws of physics as we know them, and into the unseen realms where dark matter holds sway? If these nebulae are cosmic bridges between dimensions, between different layers of existence, then perhaps the fabric of the universe is far more interconnected than we ever imagined. One of the most perplexing aspects of dark matter nebulae is their apparent lack of interaction with normal matter. Unlike gas clouds, which swirl and collapse under gravity to form stars, dark matter nebulae remain invisible, detected only by their gravitational influence. But what if that isn't the full story? What if dark matter does interact with itself in ways we cannot yet perceive? Some theories suggest that dark matter might have its own version of forces, its own equivalents of electromagnetism, strong nuclear forces, and even dark photons that carry signals across its hidden structures. If that's the case, then dark matter nebulae might not be lifeless clouds at all. They might be active, evolving structures that change over time, shaped by forces beyond our comprehension. Consider what that would mean. If dark matter nebulae have their own form of physics, their own hidden interactions, then they might be far more complex than we ever realized. They could be sites of unseen activity, places where processes are occurring that we simply cannot detect. What if, within these nebulae, entire structures are forming? Structures that are invisible to our instruments, but as real as the galaxies we see in the night sky? Could dark matter nebulae be nurseries for something entirely different, something that does not rely on normal matter, but instead exists in a hidden, parallel form? Some scientists speculate that dark matter nebulae could contain vast, invisible galaxies, structures made entirely of dark matter, bound together by forces that do not interact with light. These dark galaxies might be teeming with stars, planets, and even entire civilizations that we cannot see. If dark matter can clump together, if it can form structures similar to ordinary matter, then it is entirely possible that these nebulae are home to entities that exist in a way we cannot yet comprehend. Could there be entire ecosystems within these clouds, composed of dark matter organisms that have evolved separately from the rest of the universe? If so, then dark matter nebulae would not just be cosmic anomalies. They would be alternate realities, hidden within our own. And if there are civilizations within these nebulae, beings made of dark matter, shaped by entirely different physical laws, then could they be aware of us? Could they be studying us, just as we are attempting to study them? If these entities exist, then their understanding of the universe would be fundamentally different from ours. They would not see light as we do, nor would they interact with normal matter in the same way. To them, our world might be just as invisible as theirs is to us. And yet they would still feel the gravitational pull of our stars, just as we feel the pull of their unseen nebulae. We might be two halves of the same universe, coexisting in the same space, yet separated by an invisible boundary we have yet to cross. But what if that boundary is not as solid as we think? What if, under the right conditions, dark matter and normal matter can interact in ways we have not yet observed? Some researchers propose that there could be rare points in the universe, regions where the laws of physics blur, where dark matter briefly becomes detectable, or even where it momentarily interacts with normal matter in ways that leave behind traces. Could these regions be responsible for some of the unexplained cosmic phenomena we see, mysterious flashes of energy, anomalies in gravitational lensing, or even unexplained movements of celestial objects? If dark matter nebulae can exert gravitational influence on galaxies, then they might also be capable of shaping the large-scale structure of the cosmos in ways we have yet to understand. Some scientists believe that dark matter is responsible for the formation of galaxies, acting as a kind of cosmic glue that holds everything together. But what if it is doing more than just holding galaxies in place? What if dark matter nebulae are actively directing the flow of cosmic evolution, guiding the formation of structures in ways that are not random, but instead follow an underlying pattern? Could these nebulae be part of a grander cosmic design, one that determines where stars form, where galaxies collide, and even where life itself emerges? This idea becomes even more intriguing when we consider the possibility that dark matter might not be static. It might be dynamic, shifting and moving in ways we have yet to detect. If dark matter nebulae are drifting through space, then they could be affecting their surroundings in unpredictable ways. Could they be triggering the birth of new galaxies? Could they be influencing the shape of cosmic voids, the vast empty spaces between galactic clusters? Could they even be linked to the unexplained phenomenon of dark energy, the mysterious force that seems to be accelerating the expansion of the universe? Dark matter nebulae could be more than just passive observers of the universe's evolution. They could be active participants. If these nebulae are shaping the motion of galaxies, bending the paths of light, and influencing the very structure of spacetime, then they might be the missing link in our understanding of cosmic history. And if they are linked to dark energy, then they might hold the key to solving one of the greatest mysteries in physics. What is driving the universe's expansion, and what will happen in the future? Some models suggest that dark energy could eventually tear the universe apart in a phenomenon known as the Big Rip, where galaxies, stars, and even atoms are stretched beyond recognition. But what if dark matter nebulae play a role in preventing this from happening? What if they act as stabilizing forces, counteracting the effects of dark energy and maintaining the balance of the cosmos? If that is the case, then understanding these nebulae might be the key to understanding the ultimate fate of the universe itself. And yet, for all the questions dark matter nebulae raise, we are still no closer to truly understanding them. Our telescopes cannot see them, our instruments cannot measure them directly, and our theories are still full of unanswered questions. But that does not mean we are without hope. As technology advances, as our understanding of physics deepens, and as new discoveries challenge what we think we know, we may one day uncover the secrets of these enigmatic structures. When that day comes, it will not just be a breakthrough in astrophysics. It will be a moment that reshapes our understanding of existence itself. Because if dark matter nebulae hold the answers to the universe's deepest mysteries, then unlocking their secrets might reveal truths that go beyond space and time, truths that redefine the very nature of reality. And so, the search continues. We may not have all the answers yet, but the questions alone are enough to push us forward. Because somewhere out there, in the vast, invisible stretches of the cosmos, dark matter nebulae are waiting. And when we finally uncover their true nature, it will not just change what we know about the universe. It will change what we know about ourselves. The implications of dark matter nebulae extend far beyond astrophysics. If these invisible structures are shaping the cosmos in ways we don't yet understand, then we have to ask, what does that mean for life itself? We often assume that life requires certain conditions, stable stars, liquid water, the right chemical elements. But what if that assumption is wrong? What if life can exist in forms we can't even comprehend, in places we can't yet detect? Could dark matter nebulae be home to entire ecosystems made of something other than normal matter? If dark matter can interact with itself, forming structures, then it's not impossible to imagine a universe where life evolved under entirely different rules. But here's where things get even stranger. If dark matter nebulae can shape galaxies, bend light, and influence the motion of celestial bodies, then could they also have an effect on biological organisms? Could there be a link between dark matter and consciousness? Some scientists have speculated that dark matter might play a role in neurological processes in ways we don't yet understand. While this remains purely theoretical, it raises an intriguing question: could dark matter nebulae be influencing not just the universe, but also the very way we perceive reality? If dark matter has some unknown interaction with the brain, however slight, then it might be affecting human thought without us even realizing it. And if that's the case, then it opens the door to an even wilder possibility. Could civilizations made of dark matter exist alongside us, right here on Earth? If dark matter structures can exist undetected, then what's stopping dark matter beings from coexisting with us unseen? Just as we cannot perceive their world, they might not perceive ours. They could be walking through our cities, existing in parallel with us, never realizing that another form of life is right next to them. This sounds like science fiction, but when we consider that most of the universe is made of dark matter, while normal matter makes up only a tiny fraction, then the idea of a parallel dark matter ecosystem becomes less far-fetched. Even more unsettling is the possibility that dark matter nebulae could be influencing time itself. We already know that gravity can warp space-time, as predicted by Einstein's general relativity. If dark matter is exerting gravitational forces we don't fully understand, then could it be creating regions where time flows differently? Could dark matter nebulae contain pockets of slowed or accelerated time, places where the laws of physics break down in unexpected ways? If this is true, then these nebulae might not just be strange, invisible clouds. They might be cosmic anomalies where time itself is distorted. Now, let's take this idea even further. If dark matter nebulae can affect time, then could they be linked to some of the unexplained anomalies we've observed on Earth? Over the years, reports have surfaced of areas where time seems to behave strangely, places where people experience missing time, where compasses spin unpredictably, or where gravity seems to fluctuate. Could these be locations where dark matter interactions are temporarily breaking through into our reality? Could certain areas on Earth be hotspots where the influence of dark matter is stronger, subtly altering our perception of time and space? And what about the unexplained flashes of energy we sometimes detect in deep space, rapid bursts of radiation or gravity waves that defy explanation? Some scientists have suggested that these could be caused by interactions between dark matter and normal matter. If dark matter nebulae contain hidden processes, then maybe, just maybe, they occasionally release bursts of energy when they interact with the visible universe. These events could be brief, unpredictable, and nearly impossible to detect with our current technology. But let's step back and ask the biggest question of all. If dark matter nebulae are so important to the structure of the universe, if they are shaping galaxies, influencing gravity, and possibly even interacting with time, then why don't we know more about them? Could it be that we are missing something fundamental about the way the universe works? Are we trapped in a limited understanding of reality, one that prevents us from seeing the full picture? The search for dark matter has led scientists to build more advanced detectors, deep underground facilities designed to catch even the faintest sign of interaction. But what if we've been looking in the wrong way? What if dark matter isn't something we can detect with traditional methods, because it operates on a completely different level of reality? What if it isn't just another type of particle, but something far stranger, something that doesn't obey the rules we assume? This brings us to one of the most mind-bending theories. What if dark matter is linked to higher dimensions? Some physicists speculate that dark matter might be evidence of hidden spatial dimensions beyond the three we experience. If that's the case, then dark matter nebulae might not be random clouds of invisible mass. They might be intersections, places where our three-dimensional universe is brushing up against a higher dimensional structure. If this is true, then dark matter nebulae could be cosmic gateways to realities we can't even begin to comprehend. And if these nebulae are connected to higher dimensions, then what else might be lurking within them? Could they be hiding entire universes, parallel worlds that exist just beyond our reach? The idea of a multiverse has long been debated, and dark matter nebulae might be the key to proving its existence. If dark matter is interacting with other dimensions, then these nebulae might be weak points, places where the barrier between realities is thinner than normal. Could strange phenomena, like unexplained disappearances or sudden flashes of unknown radiation, be evidence of brief openings between worlds? The more we think about dark matter nebulae, the more questions arise. Are they just passive structures drifting through the universe? Or are they something far more profound, something that holds the key to understanding not just the cosmos, but the very nature of existence? If dark matter is connected to the fundamental structure of reality itself, then these nebulae might be more than just scientific curiosities. They might be the missing pieces of a puzzle we've been trying to solve since the dawn of human thought. The search for answers continues. As our technology improves, as we push the boundaries of physics, we may one day unlock the true nature of these enigmatic structures. And when we do, it will not just be a moment of scientific triumph. It will be a moment that changes everything we know about the universe. Because dark matter nebulae might not just be clouds of invisible mass. They might be the threads that hold reality together. If dark matter nebulae truly hold the threads of reality together, then understanding them might be the key to answering some of the most fundamental questions humanity has ever asked. What is the universe made of? Why does it exist in the form that we perceive? And perhaps most profoundly, what lies beyond the limits of our perception? These nebulae, hidden in the darkness, may contain the missing links that connect everything we know about space, time, and the unseen forces that govern the cosmos. But before we can even begin to answer these questions, we must confront a more immediate problem. How do we study something that we cannot directly observe? Traditional methods of astronomical observation rely on light, whether it be visible, infrared, ultraviolet, or even radio waves. But dark matter, by its very nature, does not emit, absorb, or reflect light. It is entirely invisible to conventional telescopes. This means that the only way we can study dark matter nebulae is through indirect means, by analyzing their gravitational effects on the objects around them. One of the most promising ways to detect dark matter nebulae is through gravitational lensing. When light from a distant galaxy or quasar passes through a massive object, such as a cluster of galaxies, the gravity of that object bends and distorts the light, sometimes creating multiple images of the same celestial body. This phenomenon, predicted by Einstein's theory of general relativity, allows astronomers to map out the distribution of dark matter by observing how it warps the light of background galaxies. If dark matter nebulae exist, they should create subtle but detectable distortions in the fabric of spacetime, revealing their presence even if they remain invisible. However, gravitational lensing alone is not enough to fully understand these structures. Scientists are also turning to simulations, complex computer models that attempt to recreate the evolution of the universe based on our current understanding of physics. These simulations suggest that dark matter is not evenly distributed, but rather forms intricate web-like structures that stretch across the cosmos. If dark matter nebulae exist, they may be regions where this cosmic web is especially dense, forming vast, interconnected filaments that shape the formation of galaxies and even entire galactic clusters. And this brings us to an even deeper mystery. If dark matter nebulae are real, then they must have formed in some way. But how? Normal nebulae, made of gas and dust, form through well-understood processes, either from the remnants of dead stars or from regions where interstellar material is dense enough to collapse under its own gravity. But dark matter does not behave like normal matter. It does not clump together in the same way, because it does not interact with itself through electromagnetic forces. This raises a crucial question: are dark matter nebulae true clouds, similar to their visible counterparts, or are they something fundamentally different? One possibility is that these nebulae are actually concentrations of primordial dark matter, left over from the earliest moments of the universe. According to cosmologists, dark matter likely formed before normal matter, shaping the large-scale structure of the cosmos long before the first stars ignited. If dark matter nebulae exist, they could be ancient relics, vast, invisible structures that have remained largely unchanged since the dawn of time. But if dark matter nebulae are that old, could they hold secrets about the origins of the universe itself? Some theories suggest that dark matter could be linked to hypothetical particles that existed in the earliest moments after the Big Bang. If so, then studying these nebulae might provide a glimpse into a time before atoms, before stars, before galaxies, when the universe was nothing more than a seething mass of high-energy particles, shaping itself into the cosmos we see today. And yet, as we probe deeper into this mystery, we find ourselves facing a paradox. If dark matter nebulae are so important, why haven't we detected them directly? Why do they remain hidden, even as we refine our instruments and push the boundaries of physics? Some researchers speculate that we may be looking for dark matter in the wrong way, that our current models are incomplete, or even fundamentally flawed. One controversial theory proposes that dark matter might not be a form of matter at all, but rather a manifestation of some deeper, unknown force in the universe. According to this idea, what we perceive as dark matter could actually be a flaw in our understanding of gravity itself. If this is true, then dark matter nebulae might not be physical objects at all, but instead regions where the laws of physics behave differently than we expect. This would be a radical shift in our understanding of the universe. It would mean that dark matter is not a substance, but rather a phenomenon, a clue that the fundamental rules governing reality are not as simple as we once thought. If dark matter nebulae are places where these rules break down, then studying them could reveal entirely new aspects of physics, ones that we have not yet even imagined. But what if dark matter is something even stranger? What if it is not just another component of the universe, but rather something that exists outside of it entirely? Some physicists have speculated that dark matter might be a remnant of a higher dimensional reality, seeping into our universe from an unseen realm. If this is true, then dark matter nebulae might not just be cosmic structures. They might be weak points, places where our three-dimensional reality brushes against something far more complex. Could these nebulae be windows into other universes? Could they be portals to dimensions beyond our own? If so, then studying them might not just teach us about dark matter, it might change everything we know about the nature of existence itself. And if that is the case, then the mystery of dark matter nebulae is not just a scientific puzzle. It is a question that goes to the very heart of reality itself. What is the universe? What lies beyond the limits of our perception? And most importantly, are we truly alone in this vast, unseen cosmos, or are there forces, civilizations, or even entire realms of existence that we have yet to discover? If dark matter nebulae are more than just invisible clouds of unknown matter, if they are instead distortions in the very fabric of reality, then their existence could hint at something far more profound than we ever imagined. Imagine for a moment that dark matter is not just an ordinary substance, but a kind of shadow material, a relic of forces that do not obey the same laws of physics that govern normal matter. If this is true, then dark matter nebulae could be the key to unlocking a new realm of physics, one that extends beyond our current understanding of space, time, and even existence itself. Some researchers have speculated that dark matter may be connected to a hidden sector of the universe, sometimes referred to as the dark sector. This concept suggests that dark matter is not just a single type of particle, but an entire hidden reality, complete with its own forces, interactions, and possibly even its own forms of life. If this is the case, then dark matter nebulae could be places where these hidden forces interact with our visible universe, creating strange and unexplained gravitational effects. What would it mean if these nebulae were, in fact, bridges between the visible universe and this hidden dark sector? Could they act as cosmic gateways, allowing energy, particles, or even information to flow between these two realms? If so, then dark matter nebulae might not just be invisible clouds of mass. They might be something much stranger, something that defies our current understanding of reality. One particularly intriguing idea is that dark matter nebulae might be remnants of an earlier universe, structures left behind by a cosmic cycle that existed before our own universe was born. Some cosmologists believe that the universe undergoes cycles of expansion and contraction, with each cycle giving rise to a new cosmos. If this is true, then dark matter nebulae could be the last remnants of a universe that existed before our own, echoes of a time when the laws of physics were different from those we know today. This idea leads to even deeper questions. If dark matter nebulae are relics of a previous universe, could they contain clues about how our own universe came into being? Could they hold the secrets of a cosmic rebirth, a process that repeats itself endlessly across eternity? If so, then studying these nebulae might not just help us understand dark matter, it might help us understand the origin of everything. But there is another possibility, one that is even more mind-bending. What if dark matter nebulae are not just passive structures, but active entities? What if they are not simply accumulations of invisible mass, but something alive in a way that we cannot yet comprehend? Some scientists have speculated that dark matter could be composed of exotic particles that do not interact with normal matter in the way we expect. If dark matter has its own complex interactions, its own equivalent of chemistry and physics, then dark matter nebulae could be places where entirely different forms of structure exist. In other words, these nebulae might not just be cosmic clouds, they might be ecosystems, filled with phenomena that we cannot see or detect. Could there be dark matter planets hidden within these nebulae? Could there be dark matter stars, powered by forces that are completely alien to our understanding of physics? And if so, could there be something even stranger, dark matter life? This might sound like science fiction, but some physicists take the idea seriously. If dark matter has its own set of interactions, then it is at least theoretically possible that it could form complex structures, just as normal matter does. And if complex structures can form, then why not life? Imagine an entire civilization hidden within a dark matter nebula, beings that exist outside the realm of our perception, living in a reality that intersects with ours but remains invisible. What would such beings be like? Would they be aware of our existence? Could they have developed their own forms of science, their own technologies, their own ways of perceiving the cosmos? And if so, could they have already found a way to observe us, even if we cannot yet observe them? The implications of this idea are staggering. If dark matter nebulae are home to forms of existence that we cannot see, then our understanding of the universe is profoundly incomplete. We might be surrounded by entire civilizations, hidden in plain sight, occupying a realm that we have yet to explore. And if that is true, then the greatest discovery in the history of science may still be waiting for us. A revelation that could change everything we think we know about life, the universe, and our place within it. But even if dark matter nebulae are not home to unknown life forms, they still pose a challenge that is just as profound. If they truly exist, then they must have an impact on the evolution of galaxies, the motion of cosmic structures, and even the fate of the universe itself. If they are massive enough, they could act as gravitational anchors, shaping the large-scale structure of the cosmos in ways that we have yet to fully understand. Some researchers believe that dark matter nebulae could be responsible for some of the strange anomalies we observe in the universe. For example, certain galaxies appear to rotate in ways that defy conventional physics, as if they are being influenced by invisible forces. Could dark matter nebulae be the missing piece of this puzzle? Could they be exerting unseen gravitational effects, altering the motion of galaxies and reshaping the universe in ways we have not yet grasped? And if they are, then what does this mean for the future of the cosmos? If dark matter nebulae play a role in the large-scale structure of the universe, could they also influence its ultimate fate? Will they help to determine whether the universe continues expanding forever, collapses in on itself, or transforms into something entirely new? These are questions that we cannot yet answer, but they highlight just how much we still have to learn. Dark matter nebulae may be one of the greatest mysteries in modern astrophysics, but they are also one of the most tantalizing. They challenge our understanding of reality, pushing us to reconsider everything we know about the nature of existence. And as we continue to search for answers, one thing becomes increasingly clear: the universe is far stranger and far more mysterious than we ever imagined. Dark matter nebulae could be more than just cosmic oddities. They might be a crucial key to understanding the very structure of the universe itself. If these invisible clouds of dark matter truly exist, they could serve as gravitational scaffolding, shaping the formation of galaxies, stars, and cosmic filaments. But what if they are even more than that? What if they are remnants of an ancient force, one that predates the universe as we know it? Some physicists speculate that dark matter could be linked to primordial black holes, hypothetical objects formed in the earliest moments after the Big Bang. If dark matter nebulae are connected to these ancient cosmic remnants, then they might not just be invisible clouds of mass. They could be fossilized echoes of the universe's birth, containing traces of physics that no longer exist in our visible cosmos. Could these nebulae contain hidden gravitational wells, warping space-time in ways that make them undetectable by traditional means? If so, they might be the missing link between dark matter and the mysterious forces that govern the infant universe. Another intriguing possibility is that dark matter nebulae are regions where dark energy and dark matter interact in ways we do not yet understand. Dark energy, the force driving the accelerated expansion of the universe, is one of the greatest mysteries in modern physics. If dark matter nebulae are somehow tied to dark energy, they could be playing a role in shaping the fate of the cosmos itself. Could they be acting as cosmic batteries, storing unknown energy that influences the expansion of space? Or could they be something even more extreme, localized distortions where dark energy pools and collects, affecting the motion of galaxies in ways we cannot yet measure? If dark matter nebulae are responsible for anomalies in cosmic expansion, then they might be influencing not just individual galaxies, but the entire structure of the universe. Some cosmologists have suggested that the distribution of dark matter throughout the cosmos resembles a vast, interconnected web, a cosmic skeleton that holds galaxies together. But what if dark matter nebulae are not just passive structures within this web? What if they are active components, shifting and changing over time, reshaping the fundamental architecture of reality? This leads to another mind-bending possibility. What if dark matter nebulae are more than just physical structures? What if they are distortions in the fabric of spacetime itself? Some theories suggest that dark matter could be linked to extra dimensions, hidden layers of reality that exist beyond our three-dimensional perception. If this is true, then dark matter nebulae could be places where these extra dimensions interact with our universe, creating gravitational effects that we interpret as unseen mass. Imagine for a moment that dark matter nebulae are not simply invisible clouds of particles, but portals, gateways to a higher dimensional reality. If our universe is just a three-dimensional slice of a much larger, multi-dimensional space, then dark matter nebulae could be places where this higher dimensional reality bleeds into our own. Could these nebulae be the cosmic equivalent of windows into a hidden realm, places where the laws of physics operate differently, where time and space behave in ways we cannot yet comprehend? And if this is true, then what lies on the other side of these hidden dimensions? Could dark matter nebulae be connected to something beyond our universe, a larger, more complex cosmos that we are only beginning to glimpse? Some physicists have proposed the idea of a shadow universe, a parallel realm composed entirely of dark matter and dark energy, existing alongside our own but largely invisible to us. If dark matter nebulae are places where these two realms overlap, then they could be the closest thing we have to evidence of a multiverse. But there is an even stranger possibility to consider. What if dark matter nebulae are not just connected to hidden dimensions, but to the fundamental nature of consciousness itself? Some radical theories in physics suggest that consciousness may be more than just a byproduct of biological processes. It may be a fundamental force in the universe, woven into the very fabric of space-time. If this is the case, then dark matter nebulae could be places where the boundary between physical reality and conscious experience begins to blur. Could these nebulae be cosmic nodes where information and matter intersect, where the underlying structure of the universe processes and stores data in ways we do not yet understand? If dark matter plays a role in the large-scale structure of the cosmos, could it also play a role in the emergence of intelligence and self-awareness? Some physicists and philosophers have speculated that the universe itself may be a kind of vast, self-organizing information system, a cosmic mind evolving over time. If this is true, then dark matter nebulae could be more than just gravitational anomalies. They could be the neural nodes of a vast, cosmic intelligence, operating on scales beyond our comprehension. This idea may sound like pure speculation, but it highlights just how little we truly understand about dark matter and its role in the cosmos. Dark matter nebulae challenge our understanding of physics, forcing us to confront the possibility that the universe is far more complex than we ever imagined. They may hold the answers to some of the biggest mysteries in science, questions about the origin of the universe, the nature of reality, and the ultimate fate of existence itself. As our technology improves and our ability to probe the unseen universe advances, we may one day unlock the secrets of these mysterious structures. Whether they turn out to be massive clouds of exotic particles, gravitational distortions linked to hidden dimensions, or something even stranger, one thing is certain: dark matter nebulae are one of the greatest puzzles in modern astrophysics. And as we continue our search for answers, we may find that the truth is even more extraordinary than we ever imagined. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.